0. Nice. Good morning, everyone. Thank you for joining me for day 2 of our installation training. Before we start, I just want to kind of review what we did yesterday. So everyone had a chance to check out the work downstairs after it's cured, touch it and feel it, see some of the defects that we had. Obviously, we created those defects on purpose to teach you how to fix them. So I know there was a couple raised eyebrows when they saw the defects, but
So JJ wasn't happy about that this morning. He called me earlier and he saw that and he was...
We're so proud of you guys.
You would have been in his office this morning. It was like...
but the pipes look great. So I didn't see any defects when I was there before I created them. Obviously, to be able to identify and fix defects, we got to have defects. So before we start, just a quick agenda review. Any questions from what we learned yesterday, stuff that you guys thought about?
Especially on that smaller kit, the cross-woven one.
Yep.
What's the thickness on that?
Sure. So the 12-inch wide and the 25-inch wide are both about 1 millimeter in thickness. The 6-inch, the carbon fiber tape we call it, which we use for like T-joints and other real small pipes, is a little bit less than half of that. So it's about 0.4 millimeters. So typically, if we're going to use that tape in conjunction with the heavier fabric, you'll do 2 layers of the tape for each layer of the heavier fabric. But yeah, it's much lighter. And you don't have to flip it when you saturate it because it's such a lighter fabric. So you can just saturate it from one side and it will saturate through effectively.
And that's a 6 length?
Um,
You get longer?
yes, it comes in 50-yard rolls. So if you buy a kit, like a repair kit, it comes in those 6-foot lengths, which is what you guys had. But it does come in 50-yard rolls as well.
Okay. So you can buy the bigger rolls as well to make it easier for longer pieces of
Absolutely, yeah. So those kits are meant to do like a 2-inch pipe. So if you have a real small pipe, that's enough to go like 10 times around.
Are those two cured down there, or do they still actually need to cure for?
Yeah, it's a good question. When we're down there, you guys will get to kind of touch it. You'll notice that there's still just the tiniest bit of tackiness to it. It's about 48 hours for the saturant system that we're using to reach 90% hardness, which is when we consider it, mechanically cured. So it will physically continue curing for upwards of 30 days, but it doesn't really affect the performance. So after 48 hours, you could put it back on full load, but it is not cured fully yet, and it's actually much easier to repair after 1 day because it's not quite as hard as it's going to be. So if we have to do any like cutting out of bubbles, if you catch it the next day, it's so much easier to cut out and to repair. But it is not full hardness yet. Some of our other saturating resins are faster, and some of them also have more cold temperature cure. Probably not going to be a big issue here, but we have one that'll go down to about 2 degrees and cure out. This one, you need to be at least at 10 degrees for it to cure properly. Any more questions before we get going? Awesome. This is the agenda for today. So what we're going to do is have a quick safety discussion. We're going to finish off our composite repair on the pipes with steps 7 and 8. We're going to take a break, and we're going to go back downstairs and finish off the hands-on portion, which is going to be primarily steps 7 and 8, which is going to be repairing bubbles and top coating. After that, we're going to have lunch, and we're going to switch gears and start looking at other applications for carbon fiber other than pipes. Specifically, we're going to talk about tanks There's also some infrastructure applications as well that we can talk about briefly. And then we're going to go downstairs and we're going to teach you some of the techniques on tanks specifically. So that's more or less the agenda for today. Feel free to ask questions while we talk if you have any. So before we get started, we always like to talk about safety. Did anyone have any issues? I know some of us got epoxy on their hands and on their arms. Our glove situation wasn't quite ideal, but it's a learning thing in the future. We'll get, size large gloves instead of size small, but
JJ, use it, don't use it.
On the safety side, seeing that we work with it, that's not necessary for dust masks, but only for safety specs. That's just to make sure that the resin and product that you're using is not getting into your eyes. When the product is dry, especially when you're sanding and cutting and all of that, is it necessary to start using your dust mask? Or is a respirator even something that's better to use?
So we recommend a dust mask when you're sanding, just because you're going to be sanding something that's fibrous, and so you will have the potential to get fibers airborne. You don't need a respirator. Really, the only reason to use a respirator is if you have like vapors that would go through your dust mask. So if you're using solvents, for cleanup, etc., and the smell really bothers you of the solvent, you could wear a respirator. There's never a need to wear a respirator with these products. A dust mask is more than sufficient. Safety glasses are definitely critical, especially with mixing, because if that stuff gets in your eye, it really hurts. Definitely can burn. But no issues with skin contact. Everyone was fine? All right, good.
Just the smell, the whole night.
Smell.
My age.
Okay.
Just be careful where you put your hands.
A couple of additional kind of, we'll call it safety related things. The materials themselves are not flammable. But one thing that you did see is sometimes you mix a kit of saturant and you only need a little bit of it. So this happened yesterday where we had about 3/4 of a kit. And if you just set it aside, especially on a warm day, it's pretty cool down there. So we didn't have the issue. And this is also a slower saturating resin. Some of these materials can kick off and start smoking in the bucket. So if you have a lot of volume in the bucket, especially on a hot day, there's a couple things that you can do if that happens. One, always put the material a little bit away from where you're working. It's not going to catch fire, but it can create an odor when it gets really hot and it kicks off. And I've actually seen it melt those plastic buckets on occasion. If you see one starting to smoke, you can just take a bottle of water and just pour it on top, because it'll boil the water and that's going to take away all of its energy, and the water won't mix in because they're not miscible. So after it's cured, you can just dump the water out, throw away the material. In advance, if you know you have a lot of material left, you'll notice we had 2 or 3 empty buckets from material we used. Sometimes I'll just pour half of it into another bucket, because it's just on the bulk of material. If you only have a little bit left, you don't have to worry about it. So just keep that in mind. If you have a pretty full bucket, just be aware. It's an exothermic reaction. That means it creates heat when the epoxy is reacting. If you pour it in multiple buckets, that helps, or you can always pour water on top if you notice it later. The worst thing you can do is leave it in a tank. If you're in a confined space, you never want to leave it inside the confined space to kick off. Always take it outside where it's got plenty of fresh air.
When you throw the water into it to cool it, can you then use the resin again?
No, it's hard now. It's hard, it's really gelled.
Yeah, this is after it's already past its shelf pot life. You can't use it. It's starting to kick off. Just little tips to make sure that you don't have issues in the field, because Some products are more prone to it than others. If you get into any of our acid-resistant materials, those tend to be faster because it's a different resin that we use. So specifically if you're doing like sulfuric acid-resistant materials, that exothermic reaction is something you need to worry about. For this material down here, it's really not that big of a deal. But I just like to make people aware of any of the issues that you might face. And that was really the only thing. I would say that wearing gloves when handling the carbon fiber is one thing that I noticed. A couple people were, a little overzealous and just wanted to get at cutting it, etc. There's two reasons that we wear gloves when we're handling the carbon. The first reason is just to protect yourselves. So you will get itchy if you handle the carbon with your skin a lot. I had some sales reps that went to a trade show and thought it would be cool to put a carbon fiber down as a tablecloth. And they sat there all day, like, doing whatnot. No one would do that with fiberglass, but they're like, this looks cool, let's put it down. They were pretty red and itchy the next morning, and they called me and they're like, so anyways, don't do that. But the other reason that we wear gloves is because there's oils in our hands, and those will actually absorb into the carbon fiber. And if you're a real greasy fellow, it can mess up the saturation of the carbon fiber. So make sure you're wearing gloves when you handle the carbon.
So you don't sell this stuff into grease then?
We don't sell it into grease?
Grease, yeah. No grease on it.
We don't. Not yet. But that's about it for safety. Everything looked good. Like, we did a good job yesterday. I think there's a lot to take in when we're doing this. So what I'm going to do is I'm going to finish off application steps 7 and 8, and then we're going to kind of talk through the entire process, and then we're going to go down and actually do steps 7 and 8. So as you see, steps 7 and 8 are what we call post-installation steps. So the carbon fiber's already been installed, and now what we're going to do is inspection and repairs, and we're going to do top coating. Two fairly simple steps. Like anything, when you put it in, inspection is critical. Unfortunately, with a carbon fiber, you can't inspect it the same day it's installed. You really need to wait for it to cure so you can do the inspection properly. So a minimum of 24 hours has to pass before you can go and do your inspection. I think this is actually a video with sound. So you can see it's pretty obvious just from the sounds. I don't know if the people online probably couldn't hear the sound because I think I'm not plugged in. But if you tap on the composite, you can hear a hollow sound when you're not tight against the substrate. Some applications, bubbles are more critical than others. So we'll let you know if this is a critical application where you need to repair all your bubbles. Typically, we have a threshold of 25 millimeters. If it's below that, you don't have to worry about it. If it's above that, on a critical application, you're going to need to repair it. So that's kind of your threshold. A lot of the bubbles that you're going to find in the field are going to be really small, and you won't even notice them. But as you guys saw downstairs, it's really pretty obvious when you get bigger bubbles. And these weren't fake bubbles. These were bubbles that were naturally there for people doing a wrap. So as you do longer stretches of pipe, especially pipes that are hard to reach. So right now we're doing waist-high pipes. When you do pipes that are down low or close together, you'll definitely get a lot more defects than you will on something like this. So it's good to know. Do your best to minimize defects, obviously, but we're going to teach you how to fix defects if you have them. Typically, there would be an inspector that would go through and do a visual inspection. So we don't recommend, this is called a tap test that they're doing here. We don't recommend tapping the entire pipe. What you do is if you see a spot that looks like a bubble, you'll go in and tap it. Because sometimes, there might have been a weld seam there, and there's a reason why it looks like a bump, and it's still solid. Other times it is actually an air pocket that's trapped under the composite, and this is an easy way to identify what it is. So there's several ways to repair defects. Some defects, if they're right on the edge on our overlap area, you can just cut away, like if it's something we call a lifted edge, where like the very edge kind of stands up, you can just cut it away because it will get in the way of top coating if you don't. Other defects, we can put additional layers on. So what I'm going to do is we'll go downstairs. I'll show you how we would cut away a defect, just because that's the most extreme repair. And then putting additional layers on doesn't really take any training. We'll kind of tell you when to do what. So if you're doing a critical line, which is going to be a really high pressure and something that's got dangerous materials in it, like hydrocarbon, etc., that's where you have to do a more sophisticated air bubble repair. So some of the most common defects that we see, there's a lot of superficial defects, like the lifted edge. Go ahead.
Just a quick question.
Yeah.
On the carbon wrapping you stipulated on the welding, you will also get that hollow sound. But does it make it easier just to mark in the area to stipulate where that weld is?
So you won't get a hollow sound if it's over the weld,
Okay.
is what I'm saying. If it's tight against the surface, or like if you have putty that's a little bit proud, so it's tight against the putty, it won't sound hollow like that. So by tapping it, you'll be able to tell it's not actually a bubble. It's actually just a spot that's a little bit higher on the substrate itself. But what we do is, we would mark. There's not really any time when you would say you definitely would have a bubble, but if you do, we'll tend to mark the bubbles and then see how big they are and then decide what we need to do for fixing. A lot of the most common types of defects, this was probably just somebody putting their hand on the pipe before it was fully cured. It's fairly common. So if you're working on the pipe here, sometimes you like lean back against it, or as you're working on it, your elbow can get into it. So just be conscientious of where you are. That's the most common type of defect that we see, is just somebody physically bumping into it, or stepping on a pipe or something like that when it's not fully cured. This is an example of a lifted edge. If you get something like this, because it's on our overlap, it's usually not critical, but it makes it a pain in the butt to top coat. So we'll often, if you catch it the next day, you can just take a knife and kind of chop that off, and it'll make the end product look a lot nicer. This can happen especially if you leave your overlap on the bottom of the pipe. So that's why we don't like to leave the overlap on the bottom, because that's a lot more likely to happen. So like I said, we'll walk through some air bubble repairs downstairs. Most of the time you will not be repairing air bubbles, but like I said, for the applications where you will, I like to just train you on everything you might need to know. Moving to top coat application. So our top coat comes in two colors, red and gray. If your customer wants another color, you can paint this with whatever you want afterwards. You can use a urethane if it's outside and you need color stability. You can actually just put like a latex paint over the top of it as well. So whatever they typically paint their pipes with, you can paint it afterwards if it needs to be a specific color. But we don't make like a safety yellow or a white or any like color match colors, because these are all industrial coatings. So we can't just like tint like a paint store. So the primary top coat that we use is our HP 300 epoxy. It's just a standard epoxy, zero VOC, just like the other materials, meaning there's no solvent in the material. The reason that we use this, a couple of reasons. One, it's going to help seal if there's any porosity left in that carbon fiber. It's going to be an epoxy resin. It's going to protect the carbon fiber from UV exposure. UV exposure can damage epoxies over long terms, so we don't want it to be exposed to UV. We'd rather have the top coat take the UV. If you're going to do a buried pipe, we also recommend using this because it's going to help prevent any damage to the carbon fiber during backfill. The final reason that we use the 300 epoxy for cathodically protected pipes, the carbon fiber is conductive. So we're going to put our galvanic barrier down, but occasionally there could be a void in the galvanic barrier. Definitely something that could possibly happen. So this is kind of a secondary means of making sure that you can't ground your cathodic protection. It's not necessary in every application. So there are times when you won't use a top coat. But most of the time, it's such a minor step and it looks a lot better long term when you've coated it. Most of the time we'll top coat the carbon fiber. This is what the application of the top coat looks like. So a lot of us have probably painted like with latex paint before in our lives. This material is much heavier than a latex, and you want to put it down significantly thicker than a latex. So I'll kind of show you how we do that. But the key is you're not going to get a large area when you dip your roller. You're only going to get, a couple square feet, and then you're going to have to dip again. So it's going to seem like you're dipping constantly, but that's how we're going to build it up at the required thickness. There's several ways that we can measure the thickness of it. Typically in this application, we'll just make sure that it's opaque. You can't see through it. If you can see the black carbon fiber through it, it's not thick enough. So we put the amount of pigment in to make it only, opaque when it's at a certain thickness. So if you're less than 10 mils, or I'm trying to think what that is in
250 microns.
250?
Microns, 50 microns.
50.
250 microns.
250. So if you're less than 250 microns, it's going to be see-through slightly. Like you're going to be able to see the texture of the carbon fiber. So that's too thin. For other applications, we do make coatings that don't go on carbon fiber. Excuse me. If we get into that, there's other ways, something called a wet film thickness gauge. It looks like a little comb, and you can put it down and it will tell you how thick the coating is. It'll show you. We're not going to train you on that because it's kind of outside the scope of carbon fiber. But if we ever do get into coatings, plenty of ways to measure the thickness of this. Or if you have a client that wants you to measure thickness on a top coat for whatever reason, there are means, and it's a pretty simple tool to do that.
I do have a thickness meter here if you want to show one.
A little wet film gauge? Okay. Yeah, we'll see. I mean, it's not a bad idea if you have one. So this material has about a 45-minute working time. It's a little slower to put on because of the fact that you're going to be rolling it out of a roller tray. So often what I'll see people do is, if you have 20 meters of pipe to coat, you'll mix one unit and then share it amongst two people. So you won't have the whole bucket to yourself, because a lot of times it'll kick off before you can get it all out. The other thing you can do on larger pipe is actually pour the material on top of the pipe and then just work it around with your roller, and it's way faster. But if you're not good, it can make a mess because it can drip all over. So, but it's a lot faster. So always an option, especially if you have tarping underneath. A little dripping won't make a big deal. And that can save you a lot of time and allow you to get the entire gallon out on your own. But for real small pipes, that's not really an option. The size pipe we have downstairs is kind of borderline. That's about as small as I would recommend pouring it on top of the pipe on. The other thing I'd like to mention is we see holidays on the bottom. That's an area that you missed all the time. So always, make sure you go over the bottom multiple times. Ensure that there's no holidays in the bottom, and get down and look occasionally. Because if there's an inspector that's going to come in afterwards, they're going to get on their hands and knees and look at the bottom of the pipe. If your pipe is super low and you don't want to constantly get in your hands and knees, you can get mirrors as well that you can have for just inspection before you go.
Can't you have trainees to do that?
You do, but I don't.
Your direction of painting, does it have any influence on it?
The direction?
Yeah, if it's
The way you write it.
Yeah.
So it does not. You can coat while the carbon fiber is still wet. So you don't have to wait for it to dry. So you can put this on while it's still wet. If it's still wet, you don't want to disrupt it, so I would roll more or less in the direction. The coating is not that sticky, and normally, within an hour or so, that material starts to tack up. So it really doesn't move as much as it did when it was fresh. You can see the direction that he's rolling here, around the pipe this way. It's much easier to roll that way on small and medium diameter pipe. If you roll like this way on the pipe, you tend to miss a lot more spots, unless you get to a real big pipe. And then, the pitch isn't enough that you can roll either way on a real big pipe. But I definitely recommend going around the circumference for this diameter pipe that we're working on. So you can see like down here where you can kind of see through it. So that's an area where the top coat's a little bit too thin. It's pretty easy to tell. It kind of stands out. If you're going to use multiple coats of material, we usually alternate colors. So you would use a red coat and then a gray coat. And that way, if you miss an area with the red, you'll be able to see the black of the carbon fiber. If you miss an area on the gray, you'll be able to see the red of the base coat. So obviously this is what a holiday looks like, an area where they completely missed. And you can also see in this area where it's real thin, you can see the black through. This was on the bottom of the pipe where we find almost all of our holidays. That's it for this. The last two sections of the repair are pretty simple. Before we go on coffee break, because I think we're running a little bit early, we're just going to refresh on the different tasks that go into the installation of our pipe. So, worksite preparation, general worksite preparation, just setting ourselves up for success is really critical to the application of this process. Can anyone tell me some of the things that are important to do before we start?
Sure, the pipe is clean.
Preparation.
Inspection. Checking the available space that you have to work with.
Sure. So we have make sure the pipe is clean, preparation, although that's kind of vague, inspection.
How many layers you need?
Yeah, there's a lot of stuff that's involved. If you don't know how many layers you need, you can't wrap it. If you don't have access, you're not going to be able to wrap. So just getting up next to the pipe and thinking about what you're going to be doing is really important. Also making sure you can work cleanly and safely. So worksite prep, having all the tools you need as well. So if you're ready to go but you don't have scissors, you're going to have a tough time doing this process. If you're ready to go and you only have extra small gloves, you're going to have a hard time doing this process.
JJ.
Just a quick question. If you get to a site where it's difficult to sand, difficult to cut the line, and you're sitting in a situation where sand lasts or nothing, what can you put on the line? Essentially, after you clean the line, you get all the oils and stuff off, but you can't get the paint off or nothing of that. What can you put in place to make sure that you still got a good bind to it?
Your adhesive layer.
Yeah.
So I guess I don't know exactly what you're asking. You're saying if you can't do sandblasting.
Yeah, any preparation on the line.
Um,
Would you still recommend carbon wrap or?
so it depends on the pressure and on the expected longevity of the repair. So we can do carbon wraps with other surface preparation techniques. Grinding or hand sanding can work for lower pressure lines. If this is going to be a high pressure line or like a hydrocarbon, something that if it spills into the environment has large environmental impacts, then it's really important to ensure that we get a surface preparation method that's more reliable, like sandblasting. Because when you do power tool prep, you really have to pay attention. It's a lot harder to ensure the quality of your prep. There's a couple tools, and maybe I don't have internet right now, but I can show you a couple of the tools. We were talking about like sponge blasting yesterday. There's a couple dust-free blast options. So if dust is the issue, so especially if you're in the sales side and you're talking to somebody and they're like, oh, you can't blast, then I ask why. And if dust is the problem, we can blast without creating dust. You know, there's a water vapor blast where it basically uses a little bit of water to suppress the dust. There's sponge blasting where you use a modified media. There's also something called bristle blasting, which is a hand tool. So people will like to say, oh, you can't blast. But I always follow that up with why, so that if we can convince them that we can blast, that's going to give them the best outcome long term. But the bristle blaster is kind of the second best. So what I'll try and do is I'll try and get somebody to find a video. That's a power tool that you can just buy and get.
So is this bristle blast, I think that would be the way to go if we can't go for sandblasting. Is that like a grinder with a, yeah.
Does
Can we maybe get internet and then you can show us? I just want to explore that option of the bristle blast because I know we're going to sit with the problem of sandblasting on site and
yeah.
Okay, calm down.
Hold on a second.
you know in especially Cape Town, we struggle to get the resources together and get the stuff done. So sandblasting is
The following preparation should be performed before working with the Bristol Blaster pneumatic.
There you go.
Screw the handle into the drive unit by hand. The handle is designed to guide the machine.
So this is a bristle blaster.
System and install the correct Bristol Blaster belt. Correct installation of the Bristol Blaster belt requires the bend of the Bristol tips to be pointed forward in the same direction as the rotation of the belts. Close the adapter system and tighten the screw by hand only. The correct rotational speed directly affects the performance and lifespan of the Bristol Blaster belt. Therefore, the correct Monty air pressure regulator,
Check this out, it's
depending on the
unplugged.
belt width selected of 11 or 23 millimeters, must
So
be
there's an
used.
electric and a pneumatic version of this.
The safety trigger prevents accidental starting of the machine. For best results in cleanliness and roughness, we recommend continuous visual monitoring of the surface. The following guidelines are imperative when applying the Bristol Blaster. The distance between the accelerator bar and the material surface must be about a finger width. The accelerator bar builds and then releases energy via the Bristol tips. It is at this point that the bristles have the highest kinetic energy to be transferred to the target substrate.
and you say that would be a rough
Always operate the Bristol
What
blaster,
polish it?
moving the tool side to side while drawing the tool.
So you can
toward
kind
the
of see the
operator.
roughness
I see.
that it's
Only
creating.
apply pressure with the handle on the material surface. Customize your working speed to the desired cleanliness and roughness. A consistently clean and coarse surface can be achieved by slightly overlapping each swath created with careful control of the tool. The Bristol blasting process provides an excellent alternative to traditional blasting. By using the Bristol blaster, a grade of surface preparation cleanliness comparable from A SA 2.5, SSPC, SP10 to D SA 3, SSPC, SP5, and a grade of roughness comparable
What does that
from
mean?
medium G to
Yeah, you
coarse
guys
G
can tell us.
and PG. Resulting from our patented technology, we are able to generate a roughness up to 120 microns RZ, 4.7 mil according to the steel material.
So
Since the Bristol Blaster is a dynamic handheld tool system, the
That's probably
following
enough. I
factors
think we
must
get
be
the-
considered and may influence the finish achieved. Application speed, pressure placed onto the tool when at service, angles both fore and aft, as well as side to side of the tool to the work surface.
I think we get the point.
Are you happy, Tom?
I'm happy
No,
for
okay.
driving.
As long as you're happy, man.
So that tool works, but it's slow. So if you're doing an adhesion zone, then that's definitely a viable solution. If you were going to do like 20 meters of pipe, it would take you, 10 days of prep. And that wheel that you saw them put in, it's only going to get you, a few square feet of area before the tip's dull, and you have to replace that wheel. They do make another one that's got a double head, and it goes faster when you get the double head. But again, for an adhesion zone or a small area, that's a good tool, and it works well.
So it's labor intensive, which is good. Takes longer.
Yeah, it is what it is.
And that's so you said you need 75 microns to blast to get a proper bond to your pipe. So that's about 150 or what did they say?
125.
125. So that's
Yeah.
good enough for patch repair or whatever.
Yeah, that tool works as long as you take your time. So the key to that tool is, if you don't replace the little bristle heads, after a while, you'll start to just get a lot less roughness in the surface. But you can visibly see, like, you don't want the surface to be shiny. You want it to look dull and matte and feel a little bit like sandpaper. So, yeah, that's a decent tool and something that in certain areas where they don't want you to blast is an option. I still would push back at why they don't want you to blast, because if you can do sandblasting, it's so much faster and it gives you a better profile than that tool. But that tool is the next best thing.
Yeah, I've seen it where only sanding was taking place, hydrocarbons, and you could physically take the carbon back and just put it behind.
Yeah, and that's one of the things about using this carbon fiber technology. If we're reinforcing a non-leaking pipe, the adhesion is not as critical, because all we're looking to do is make it so that the steel can't, flex out. So in areas where it's external corrosion, there's no internal corrosion, and we're reinforcing it, it's less critical. In areas where you're going to have a through-wall failure, so like either there's already a leak seal that you're putting on, or there's continued internal corrosion, adhesion is much more important, because that's the area where you'll get material leaking out. So there are times like that where I would say you can get away with just sanding, and it actually doesn't matter. You're right. You could, if you hand sand it, on our system, what I've seen is, you usually would need to take a chisel and get it started, but then you could peel it off. When you grit blast it, you would have to chisel it away the entire time. You really can't get it off at all. So there is a big difference in adhesion. But just because you can peel it off doesn't mean it wasn't serving its purpose. But if it was a leak, it's not going to work for a leak.
So So essentially one surface prep, if there's a leak, especially on hydrocarbons, because it's a critical system now,
Hmm.
and if you only sand it, then you're not getting the bond to the material that you want.
Yeah, and if the customer is fine with a temporary repair, you can get away with a temporary repair sanding it like that in many cases. If they want to get 6 months till they're in an outage before they can do a proper repair, you can get away with that. But I don't like to do a permanent repair on a leaking pipe with only sanding because it's going to fail at some point. Setting the expectations is really important with the customer.
So
You know,
sandblasting is the way to go.
sandblasting is the way to go. This way also works. It's just slower. The bristle blaster, that is. So bristle blaster will get you the adhesion that we need for a permanent repair. Hand sanding will not, unless there's no internal corrosion. And then at that point, adhesion is less critical. So we can get away with moderate adhesion because we're just structurally reinforcing. We're not doing a leak stop.
So how would that bristle blasting work on pitted piping?
On which kind?
The bristle blasting
Yeah.
Corroded
on
pipe.
pitting, how, does it work well?
Yeah, it's fine. It works well on pitted pipes. What I would say is typically, if you're going to just do a spot repair, then you would have to go over the pitting. If you're going to do an adhesion zone repair, we'll usually move outside and find smooth pipe, and then the center will be the pitted area, and that makes it easier. It is easier to bristle blast on smooth steel. So surface preparation is definitely going to be important to this and kind of the linchpin of a proper application. Understanding the restrictions. If you have questions, especially as this is fairly new, communicate with me and Morali and we'll steer you in the right direction on if the surface preparation your client allows is adequate or not. So, we've done a lot of different repairs. It's impossible for you to kind of learn all of our knowledge in a short period. I don't want to get too over the top with the specifics, but there's definitely times when sanding is acceptable, on other metals. So we've done like copper piping. Sanding is actually a pretty decent tool because it's a lot softer metal. But on steel, it's difficult. The high strength adhesive definitely helps as well if it's marginal surface preparation. So that's another tool that you can use to just enhance the adhesion when you can't do the proper grit blasting. We didn't install galvanic barriers, so we'll do a little bit of galvanic barrier installation when we do our tank coating material later on this afternoon. Do people kind of understand what the galvanic barrier is and what the process there is? Yes, more or less?
Yeah.
So it's something that, again, with a cathodically protected pipe, you're going to have to put that in place if it's a metal pipe and it's cathodically protected. So it's just a good habit to get in. If it is a non-metallic pipe, like concrete or plastic, you never need a galvanic barrier. But if it's a metallic pipe and it's cathodically protected, which most things at like a refinery will be, you'll usually put a layer of fiberglass in first. It's only a single layer, and we don't count that as part of the structural reinforcement. It's just a layer put there for electrical insulation. So the application of the carbon fiber itself, can anyone tell me some of the keys to applying carbon fiber correctly?
Cut straight.
Definitely helps.
Don't have bubbles.
What was that?
Don't have bubbles.
Press the bubbles, don't wrap it too fast, press the bubbles as you go.
Good saturation, not oversaturation.
Yeah, so we had a couple of times when there was a little bit too much saturant. It's really obvious, right? It gets drippy, it gets messy. Communication is important. You know, we're all on the same team. Don't feel like, you know, you're critiquing someone if you're telling them, hey, this is a little oversaturated. It's going to make the process better. It's a lot easier to put on a piece that's properly saturated. So the one thing that I noticed that we had a little bit of trouble with is the wrap direction. So it is important to always wrap in the same direction. So what I recommend is, we were switching around yesterday. That makes it even harder, right? If you were saturating and then you go to wrapping. In an actual job, don't switch around like that. You know, if you're wrapping a pipe, stay on the same side and wrap from that side, because you'll just get used to wrapping in that direction. If you switch sides, all of a sudden, it's going to feel like you're wrapping the wrong way. So, like I said, if you have a partner, stay on the same side. Don't switch it up. You know, don't switch people around at roles. Definitely let people get really good at the role that they're doing. Saturation is another thing that takes time to really get down just right. So it just takes practice. So some people are a little faster than others at saturating, but let people get that practice. You know, if someone's consistently having issues with saturating, there's other roles that they can do. The runner is another thing that's usually really important. So here, you can saturate right next to your pipe, but that is not always the case. So there's a lot of times if you're, say, doing a repair on scaffolding, where you can't set up your saturation table up on scaffolding. So what we'll do is, we'll saturate out and roll up the pieces on those tubes and put them in a bucket, and you can just lift it up to the people who are there. But it's really important to know what size fabric pieces you need, because we're changing sizes. So there was a lot on your plate yesterday. You had to think about how to saturate, the direction of wrapping, a lot of different things. As you don't have to think about some of those because you've done it, it gets easier. Other things are going to crop up. You know, knowing what sizes are going to be coming next, so that you can tell the saturator in advance, hey, we're going to need 4 25s and then a 12. And then the saturator knows, all right, let me get 4 25s out. I'll go to a 12. And when they get close, they'll ask the runner, what am I going to need coming up? To optimize, you continually want to saturate. So if you're the saturator, you should never be not saturating until you're almost done with the job. So it's really fast to put that sheet on, as we saw. It's a little bit slower when you have irregular shapes, but it's still pretty fast to put the sheets on. So if you don't know what sizes are coming up, that's where you'll have a runner and you'll be like, hey, figure out what sizes they're going to need so I can keep saturating. So if you saturate the wrong size, you can just roll it up and set it aside until they need it. So it's typical that, you know, you're going to need every now and then the shorter piece of fabric. So, you know, if you don't know what you need, don't just wait around for 20 minutes. You can definitely guess and saturate, and if they don't need it quite yet, it's going to be fine sitting there for 15 or 20 minutes until they need it. Otherwise, like I said, I thought it went pretty well yesterday. The end products looked good until I messed them up and created bubbles. Whenever we do this work, I find that a lot of people come out and watch and want to see what you're doing because, you know, the carbon fiber kind of looks cool, and and it's definitely a great point to be able to, you know, talk to them about other applications, etc. when people come out and check it out. So I always welcome people to come out and watch as you're doing the work. Gives you the chance to see, to talk to them about problems that they're having where this might be a good solution. Excuse me. So that's really all I have on the presentation for this morning. What we're going to do downstairs, we are going to, let's see my facilitation guide. We're going to try to set up a T-joint. So we had made a T-joint. I don't know if it's set up yet or not. We're probably going to have to take down one of the pipes so we have enough pipe supports. But we're going to try to set up a T-joint. There's only going to be one. So what I'm going to do is I'll have the people who are actually going to be field installers suit up, and we'll put on the T-joint, and everyone else can just kind of watch to get an idea of how we do a T-joint. It's really not that much more difficult, but it is a slower process whenever you have a joint or an interruption. We are also going to do top coating and air bubble repair. We'll probably start with air bubble repair and top coating because those are going to be on the pipes that we did yesterday, and then we'll move forward onto the T-joint. So let's grab a coffee or a water, take a few minutes, and in about 5 to 10 minutes, we'll meet downstairs and we'll get suited up.
second one.
But if this was continuous, you wouldn't finish it like that. You'd have one finish, the first one finishing there, the second one there, the third one here.
Maar dat is alleen, hè? So they overlap the switch.
Each one, you still wrap the area that you board.
Of wat overhang. Ja, jy wil eintlik in hierdie kwart. And after the day, in the industry, because
I'm guessing it would be preferable to do everything in one day. So that they don't have
If it wasn't for that fucking thing, yeah, so it depends. But I'd be sitting in the garden and eating fish. See, yesterday, I had 2 people.
I did pull myself.
What about this?
You're gonna unless you work. Like sort of an automation of the work.
So now I believe it takes 3 weeks to get through this. Used to take 1 week.
Something in best practice. It's like you can have your guy wrapping, you can have your guy massaging it, and you can have a guy on the table. But no less than 3 people.
just give me into the taking out. I'll go wherever. So it's just into the installation. So that. Ja, maar die basic. Maar het staat soms like twee staat in die camera.
I prefer to be the massagee, not the massager.
Oh. Well, I like to probably lie down and we'll wrap it around.
I like to be the pipe.
Not that I'm bragging. It takes some time to set this shit, man. It's going to be a bit of a limiting factor as well. Not really one of those things. Nah, if you look at that, and you listen to what Tommy was saying about what happened on site, this is very hard.
Ja, maar ons sit in elk geval by gewoond en so niks. Maar wat sal verskil is nou die trouletjie wat ons hier.
Exactly what
Sal
you
ons dan fully kit doen.
So those little two factory boxes are
Pakkie hout,
same thing. The guys what they do.
bokkies aan die onderkant het, voordat sy tot ons breër is. En jy kan hom net toeslaan en opslaan.
What they do is they use the tree and they
Dit is like 'n hoë pattern, my staple gun kry, plastic kry, en jy vastrek dit. Ons dit met tafel, met die plastic aftrek as dit klaar is, en dan kan ek net weer sheet met
Pick it up.
Ek het al klaar, gisteraan gelê slaap op die tafel.
Painted, a little 1 liter painted.
En dan kan ek die tafel 'n bietjie langer maak.
And it actually opened up, it heated up.
Dan kry ek net vir my 25 mil plywood.
You sealed it. All that was sweat. They gave you the resin.
Hierdie kan ek ook my tafel bietjie breër maak.
Oh, all of this must go in.
So dan as ek kan 'n tafel werk, nee, is daai dit is
No, don't read the instructions.
No, it didn't come from the truck.
ander ding wat is cheap.
Can you read it after the...
And then it's actually you got a little squeezy bottle, little squeezy bottle like that. And heat it up and work it out. I start boiling the onions, spitting.
Ek weet wat se naam is met weer dan. Nee, maar Tronox is met daar waar die sand was.
Yeah, I still want to ask the question, how strong is this stuff? Is it one fucking train.
freaking wat noem ons dit titanium lyn aan daar. But that's like one of my questions. Gebruik dit net. But hulle kan jou dan wel voor die gehoor het. Dis wat jy nou aan daar.
The stones in your shoes.
Sien hoe lê die wel splinter nie. Hulle het net nie 'n shirt nie, hulle kan nie 'n shirt kry.
Al die kabel wat ons hier gebruik het, ons 'n vlerk gebou het vir F1 karre te sit.
Nee. Ons gaan 'n vlerk gebou het om te vlieg. My pa sal dit van inspek ook. Sê van dan wat.
Jammer nie met die vlerk.
Ja,
Ek like dit dat dit 'n vlerk is.
But you don't want to fuck it up. You want to get it right. Get rid of the evidence, huh? She's getting rid of the evidence.
He was here this morning when I pitched the operations. After hours, you got no
You'll actually be amazed how much you can get done. No one fucking phone. No, it's good.
with a glass of wine and a bit of music in the background.
Yeah, maar geen speel dan my. Hy is 7 jaar lank saam met my. Elke oggend gelyk. Is hy, wat is die musiek luister?
This is a millennial. He rolls into artificial intelligence because he doesn't trust his own.
80s, no? 80s. 80s is the only music.
Hey, he was still a bad dad in the 80s. He was only born in 2000. He wasn't even a dirty thought. There we go. Artificial intelligence. The problem with artificial intelligence is it makes you lose your realistic.
I've watched Terminator enough. I don't know much of it.
But it's either you join it or you're against it. Either you go onto the
All right, everyone. If everyone can gather round. All right, guys, all the way over here. Come in close. Don't be shy. All right, guys. What we're going to do now is we're going to look at how we can repair some defects. This material was put on about 24 hours ago. So as you can tell, it's tack-free, but it's not fully cured. Like I said, it's about 48 hours for it to get its full hardness. So there's a little bit of flexibility to it. It's going to make repairing any issues a lot easier for us. So I can pretty easily cut something like that off. Tomorrow, you're not going to be able to do that so easily. So if you do have any issues, it's always good to check it out the next day as quickly as you can. Because if you're going to top coat this, it's going to be a pain in the butt. But if we can get this as smooth as possible, it makes your life a lot easier, and the end product will look nicer. So a knife also works really well for cutting through. The key when you're repairing something like this is don't make it a bigger problem. So if you really cut down, you can cut into the carbon fiber. So as you're removing defects like this, just be careful and do it gently, like a little bit at a time. Don't try to cut it all away at once. And I'm not going to cut like this, because that is going to cut through too far. So you'll notice when I'm cutting, I'm doing it in a manner that is not going to cut deeper into the defect. So it's pretty easy to remove. The best policy is to, not let these things happen. But if they do happen, it is what it is. We can fix it. I did create actual air bubbles, so I don't know if you can see any here. On this side, oh. So for some real large air bubbles, we actually will want to cut them away. But the air bubble is also pretty easy to cut away. Again, it's because we're only one day in. So you saw how easily I can just cut that away. What we would do on an air bubble like this, because this is a fairly large air bubble, if you identify that, we would just cut that away and put 2 additional layers of carbon fiber on it. If it's a smaller and much smoother air bubble, because this one sticks up pretty far, if we just wrapped over the top of that, you would need to putty it first to smooth it off, and then you could wrap it without cutting it away. But sometimes it's easier just to cut it away, then we don't have to use the putty. It saves us a step. You'd have to mix a whole kit of putty to basically just put a tiny little bit here. Either are viable. But if you catch it on the next day, you can just cut it away, wrap over it again. So what I'm going to do is have each person, each team, go back and cut away a couple of your air bubbles.
Is 2 layers the default, or is actually a full 6-layer wrap? Should it actually apply any other additional 6 layers?
So the reality of the air bubbles that we catch is they're almost always on the outer 2 layers, because you keep wrapping it again and again. It's very rare that we get an air bubble defect that's deep. In fact, if this was 6 layers deep, you wouldn't be able to hear it because it will sound solid. And a defect in the middle of our system is actually the worst case in terms of like the effect on the pressure capacity. If it's on the top layer or on the very bottom layer, it has less of an effect. So typically when we cut it away, if you want, you can get like calipers or a micron gauge to see how thick this is. And then you'll know what layer you were at. So we have some clients that make us measure every time we cut off an air bubble and replace. So if we can show that this is on the outer layer, we would then do 2. If this was 2 layers down, we would then have to do more layers when we repair it. So you can do that. That's definitely, a viable option. Putting 2 additional layers, the reason that we do that is we're not trying to just rebuild the system from the ground up. Like if you have to cut in and you get down to the pipe, if you mess up and you accidentally cut down, you will have to put the full number of layers on. But as long as you can remove the air bubble like I just showed and only take off a limited number of layers without interrupting the carbon underneath, then you don't have to put the full, say, 6 layers on.
When you do put extra layers, because on top of each other, what width, how far away from the bubble, what's the coverage on either side?
Sure, sure. So again, it depends on the size of the bubble. So we definitely would, if we had a bubble right here, we would center it, the wrap, and we could get away with a 12-inch wrap, this width. If the bubble was bigger and it's within a couple inches of the side, you might need to do a 25-inch wrap. But you definitely want a few inches on either side so you can totally enclose the bubble.
And not staggered in any way, just on top of each other.
Yeah.
This doesn't need any surface prep again, you can just have
Because we're within our overcoat window, you can just wrap right over it without any surface prep. It's going to stick great. In about 5 days is what our overcoat window is on this product, is 5 days. After about 5 days, it's not going to stick anymore, so you'll have to sand it. So you're going to get it as smooth as you can. You can do a little bit of sanding. So we have sandpaper, but just where the bubble was to make it smooth. You don't have to sand the whole circumference because we're not sanding for adhesion. We're sanding to make it smooth. So there's cases where you need to do a little sanding right at the spot. Well, if you got it that same day, like we just did, you'd be able to do that. But a lot of times, if this is outside, it's going to be warmer. You're probably not going to be able to do that. I would just cut the whole thing away. And then if I need to sand a little bit, and then just wrap over it.
But what I'm saying is, if there's a bubble like this underneath and you can't bend this down,
Yep.
so I cut this whole piece down.
Yes.
Okay, so because it's still a bit wet and tacky, you can do that to it.
Yeah.
That should be fine and sufficient as long as it's not close to the sides, then I can just do it 2 wraps.
If it stays. So if you push this down and it stayed like this, then that would be fine. And this looks like it would stay. It's a rarity that you're going to be able to do this because it's, like I said, it's fairly cool in here. And we did this probably less than 24 hours ago. So it's at a point where it's still pretty pliable. But yeah, if you ran into this, I would have no problem with doing this and then wrapping over that. Actually save you some time.
So your ideal window would be closer to like 8 hours for these type of things, make it a lot easier.
It's still going to be sticky after 8 hours. So unless it's a really hot day, it's in the sun, then 8 hours will be ideal. The reality is you didn't have any defects that you were going to need to fix. I created these defects. Defects are more common when you're doing large runs of pipe because anyone just, if you're doing the same thing again and again, you have more likely to have defects. Also, pipes that aren't straight and flat. If you have T-joints, reducers, if you're going over a flange or something like that, you're much more likely to have it. So there's certain areas that we know are high probability of defects. In straight pipe, chances are you're not going to have any. And the other thing that I definitely recommend doing is before you clean up for the day, so it takes a little while to clean up, right? It doesn't necessarily, if you have a 4-person crew, you're wrapping this pipe, it doesn't take all 4 of you to clean up the table. So if one person goes in and just checks over the wrap again before the end of the day, you can fix these defects before they happen. So I created these defects yesterday after everyone had left. If they were there, I could have fixed them. Like the material was still pliable. So doing that kind of like post-inspection before the material cures is actually your best defense against defects.
If you get a defect like this, you can easily spot it and say, okay, you can cut it away. But what if it's a smaller defect like this? You just drop over it.
Yeah, so if it's a small defect, less than 25 millimeters, you don't have to do anything. So like these defects, we would just do nothing. These are too small to have an effect. Yeah, so these ones, we would leave and not do anything. This one is a little bit too big. And even this one is probably almost 50 millimeters in length. And when I say 25 millimeters, whatever the longest dimension, because these are obviously oblong defects. The other thing you can do, if you're having issues with bubbles, a constricting wrap does help reduce the size of your bubbles. And that would just be a plastic wrap that you put around on the outside, and you put some tension on it. So if you're having issues with bubbles in the future, you want to explore that option, that's completely fine. That's something you can do. Most of my clients don't have major issues with bubbles unless they're on really difficult substrates. Yeah, so let's all go ahead and go back to the pipe that you started with. We only have one knife, but it doesn't take very long. So if you want to cut out a bubble, just see what it's like. Again, let's let the people who are going to be in the field actually doing this, because we have a limited number of bubbles. We'll let them do this. Fair enough. You guys want to cut it first? Yeah, be careful with these. Do we have top coat? I don't even know if we...
Kunnen we nog eens een mooi weer gaan vertellen van de eerste wordt er die mensen
As hy droër was van jou kant, dan net oormaak. Ja, maar sit op die slaap, dis een en een uitgeskryf.
Alright guys, are we all done with our air bubble repairs? Yeah. Alright. The next thing we're going to do is top coat these pipes. So, each of these is going to need a roller setup. We're only going to mix one kit of top coat. We're going to share it amongst the three groups. Sorry about that. So we're going to do a top coating right now. So we have our HP 300 epoxy in red. We're going to go ahead and mix up the HP 300 epoxy. We're going to share it amongst all three groups. Everyone has their own roller set up. It's the same color. Now can they see us? Yeah. So we are mixing our HP 300 epoxy top coat.
The managing director on the line to me.
Okay.
You're watching the feed. The feed's about 2 minutes delay.
Okay.
So when you were waving, you were saying, I can't see, I'm just watching Franco mix. So then he zoomed out and he's looking forward to meeting you tomorrow.
Awesome. Okay.
I think he lands at 11. They might get you for about 12.
Okay.
So we can probably see you for 45 minutes. I think I'm meeting down there at 3 o'clock. So.
Okay. Perfect. Yeah. So make sure you scrape the sides in this one too. Oh, there we go. And yeah, use the lid. That way you won't make a mess. All right. Yeah, it's a lot thicker than like a latex paint. So you're going to notice it goes on much thicker as well, but it's supposed to. Um, so a lot of times on the top coat, what we'll do is we'll look at the surface area and we'll say, all right, theoretically you should get, you know, 5 meters of pipe per gallon, so that we won't do checks on each spot, but use that gallon on 5 meters of pipe. Don't try and stretch it to get 10 meters of pipe, because then you're not going to have enough thickness. So it's a good way of ensuring that we're getting the thickness that we're supposed to get without having to do the tedious measurement on every area. All right. So go ahead and pour it into the mixing trays, and everyone can grab one um, and roll some top coat on.
That's my question.
You'll have a fair amount extra.
I can see there's quite a bit left over. Yes, yes.
What I would say is what we recommend is definitely going to be dependent on the specific types of clients that you have and who you're selling to. So, like, we can talk a little bit more, you know, about whether we want acid-resistant products or whether you just want to stick with a general. And then if acid-resistant stuff comes up, you can get that separately. Yeah. 2 years. Yeah. Yeah. We don't need to store below 20. I mean, really, what you're looking at is, you know, you don't want to get above about 35. What we don't want is the temperature to cycle a lot, because then air gets in through the seals. It's really the the amine side, the side that's in the jugs, that is more sensitive to moisture or water. And these things seal a lot better. Those little F-style jugs seal a lot better than those buckets. So even with different temperature cycling, it's not that big of a deal. As long as it's within 2 years. I've had people use 5-year-old epoxy and it works just fine. So it's not like the materials don't work after 2 years. It's just at some point, all that thermal cycling that just naturally it has from sitting inside your warehouse is going to mess up the seal. But you can get at least 2 years. Let me just get with these guys, make sure they're putting it on thick enough. Yeah, so you can see you just don't have enough coating, so I would just dip the roller again. Is this like little chunks coming off of the roller itself? Okay. Let me see if it's happening to everybody, or you just got a crappy roller. Yeah, so you want to be a lot heavier than this if possible. So maybe about twice as much.
No, but it's fine. She's doing it forward. When is she reversing?
Yeah, it doesn't roll very well, so I'll literally just put it on like that and then move it around. It's easier to kind of move it around once it's on the pipe. And whenever you do a repair, I always want to top coat past the end a little bit because that's going to seal the end and make sure that you don't get corrosion right here at the end of your repair. And typically I would use painter's tape just so you get a nice clean line so our repairs look nice. When you do use painter's tape, as soon as you're done, you want to peel that painter's tape. You don't want to let it cure and then pull away the painter's tape because this is a pretty robust coating. Yeah, so it's pretty thin here. I would go thicker. You just need to put more on.
So you want it to look like this?
Yes. Yes, like that.
Technically, that thing is, you'd rather want to use hand than that.
Well, this will work. Try. Hold on. Excuse me, Ryan. Try it. The key to the dumping technique is you got to put the right amount on. Like you don't want to put a ton on. And all you're doing now is just moving it around the pipe. And it is a lot faster to get the thickness that you need.
So this is where you still can see the fibers, this is where you don't see the fibers, and the latex starts doing its thing.
Yeah. And you might even need a little bit more than that.
Move it with your finger.
You can move it over if you have too much, but you could just dump a little more on if you want.
Stand up when she works.
The problem with top coating is everyone is so used to using latex paint that you can like roll out and keep rolling that like this is just different, very different. And a lot of the customers or the contractors that we use are coatings contractors, so they're used to putting on this type of coating, whereas you guys are more on the mechanical side. Yeah. If you get into coating a lot, you can spray this material as well. So like if you're doing a tank, it's much faster to spray than to roll it on. Oh, you can put it on thick with a sprayer. You just need a specialty sprayer. No.
It's a bit thick to spray.
It'll spray. Yeah, you can't spray it with like a standard like paint sprayer. You need like an industrial. It's more the pressure. You need. Yeah, for spraying, really you would only do that on tanks. You wouldn't spray on pipes. But if you're doing a tank, spraying the coating can save you a ton of time. All right.
Yeah, they're going to complain a lot, they're going on vacation a lot, eh? These pipers on holiday.
As quick as possible.
So I should put more faster on them. It's actually fine.
You gonna help me with this? Let's put it over here out of the way somewhere. This will be fine. Then I'm going to put this one on. Yeah, a third stand. That's what I was thinking. I don't know how heavy these pipes are. But I was just going to put the one... I was going to at least put the base, the longer piece on here, and then see how well it fits. See how well the short piece fits into it. Let me get the top. So we'll probably want it pried onto this side like this, yeah. You just use these. Thank you. Probably. Thank you. I think it's prudent. You're right. So we'll hold off. I just wanted to kind of see whether this is going to fit tight or not fit tight. All right, that's not too bad.
Did you want to stand it straight up or?
I was going to do it this way. It's a little easier to demonstrate. No, I think...
need another buckle, yeah?
I think there's those stands and then one of these stands.
Yeah, just exactly. And then we'll just put some duct tape to hold it in place. Really what I just want to do is just show the technique and how I would measure it and pre-cut the pieces, and then how we'll wrap it. So once they're done, we'll get one more stand, and we'll set it in there, and then duct tape it on.
Yeah.
Don't worry, guys. It's not like I'm mic'd up here. Yes, but we need one additional pipe support. Okay. It'll probably be 5 to 10 minutes before we get onto it.
This thing works much better.
Yeah.
That big roller doesn't work like that. That
It-
thing sticks to it. The more you roll, the more it drags.
So that, I don't know if they're just cheap rollers. Yeah, it looks very nice. So it's better if you can see like the roller texture. That means your consistency is perfect. It's not the end of the world here. It's a little thinner, obviously, here.
So with this, you want to give it a bit of more time so it goes tacky, then you pour over more.
You can build more. You can just, it's really only limited by its sag. So you have to get way thicker than this for it to start sagging down and get drips and runs. So you can build without letting it cure.
So this means we can do another top coat over this.
Yeah, you could just pour a little more on if you wanted a little more build here. But you can't see through it, so that this would pass QC. You know, as long as you don't see the black.
I know what the consistency is, so I work towards
put it towards what the consistency needs to be. I don't want to go under that.
Yeah,
So
but
if we're looking at this, then I won't go for this, I will go for this.
if you can see some of the roller texture,
Yes.
then you know that that's probably the optimal thickness.
Okay. When the weave starts disappearing.
Yeah, yeah.
Which guide us what must be the layers, what must be the top coat, everything. But say, for instance, now your client, they got most like got painted specters also inside. So they got most also a procedure. So sometimes they will bring it or a procedure from them, sometimes to us, but what we will say within international say that for this specific guy, not for anyone to the line. So they can't interfere with international.
But the one area is like, because you're gonna strip the paint away, say to here, and so if they have a paint spec, and they say you need 250 microns of paint for their paint spec, then you can say, all right, like at the termination of our repair, you know, you can apply additional paint or coatings there at the termination of the repair. So, for instance, we're done with our repair. Let's say this is a natural gas pipe and they need it to be white, right? They're not going to want to leave it red. So I would say, do your paint spec. If you want 250 microns of paint, paint over this entire thing, and that's fine. Don't count this towards your, so, yeah. And if they want you to do it, fine, no problem. Just make sure that they're paying for you to paint it afterwards, and then that's fine. You can go with their paint spec. But this, we're really just repairing here, and then we want to make sure we don't get corrosion where we stripped it. So it's prudent to obviously coat it all the places that we've stripped it and up onto their existing coating a little bit. So if you strip coating from like here to here, I would always prep some coating past there, either just through sanding or brush blasting where you don't remove the coating so you can tie onto it. The other thing we see people do on the end of repairs is use like a tape coating for corrosion protection. So like you can literally put that like green tape that I showed and just go like right here to make sure you don't get corrosion right at the end. Not to mark it, just to, because this is a weak spot where you could get corrosion if you have external corrosion. It's protected where the composite is. But if you've stripped their existing paint, you know, is this going to be like, you know, right there might be a spot where you can get access to the steel. And if you got corrosion right in that tiny little pinhole, you know, it could theoretically cause a leak. All right, let's see if we can take this off and stand it up, because I need to steal one of your pipe supports. So, are you tall enough? Yeah, you could lean it against the side. I don't know. Does that feel sturdy? Okay. Actually, let's set it up over there so we're on the tarp. Sorry. I don't want to mess up your floor. We'll just Move this over a little bit. Okay. It was better before they started messing with it.
It's hot, yeah. Now it's getting more hotter. Like 44. Yesterday it was 44.
Too many chefs in the kitchen. You almost didn't even need to cut this one. You could have just cut that one. Yeah.
Now, this needs to be bigger actually because it can top here. What if I grind this off, I grind that piece off, then it will sit, right?
As long as it stays in place, and we can use duct tape to hold it in place as well, it's not like we're going to put a lot of like pressure and stress on it while we're repairing it.
Pretty work, you didn't get a garage section. And it's not the other way, it's also divided it.
Oliebakjes gebruiken. Die aantoer zijn. Toen kom ik kan maar computer kunnen met zijn eigen chip. Ik zoek hem nergens niet binnen.
All right. We are setting up to wrap a T-joint to show the special technique. All right, so we are going to need a saturation table. All right, guys, so I'm going to show you how we would wrap a T-joint now. First, I'm going to walk you through the process because we're going to have to cut some carbon fiber pieces. So let's make sure we have a table to cut on and also a table to saturate on. If we got a little top coat on it, you can probably just wipe it off with a rag. Do we have a tape measure?
Yeah.
Yes? Thank you, sir. All right, guys, so when we're wrapping a T-joint, The places that we have to pay special attention to are going to be obviously the joint here where it offsets. So we're going to use mostly 12-inch fabric on this one, the smaller fabric. Sorry. So we know how to wrap the straight pipe, right? The straight pipe is pretty simple. We know we use the 25-inch wide, the wider fabric mostly. Whenever we get to an interruption, we're going to switch over to almost entirely using the thinner fabric. That way we have more, each piece doesn't have to shift and move as much. So what we're going to do is, you're going to do bands as far as you can. So we're going to end our last circumferential band right up tight against the weld seam. And that's always the first step. So you're going to end right up tight on both sides. So you're up both ways, right up to the weld seam and the outside. And then we're going to put our additional pieces down. So we're going to need at least one piece on both sides that's the full circumference plus 15 centimeters. So that's going to be, assuming that it's the same, it's going to be about 83. This one's closer to 84 and a half. So we want something about 99. So we need two pieces that are going to be 99 centimeters. Now, when we're doing this, we're going to have different length pieces. All of our pieces are not necessarily going to be 99 centimeters. So we're going to have to keep track of which one is which. So I would recommend having maybe 2 boxes and labeling what the length are. So we're going to need some 99 centimeter pieces, at least 3, because we're also going to put one around here. The other pieces are going to basically drape over the T-joint. So they may be slightly longer. I would kind of measure it. I think 99 is actually going to be fine for all of them on this particular joint. So let's cut about 10 pieces to 99 centimeters, all with a 12-inch fabric. Yeah, we would probably putty this to make it, a real T-joint wouldn't look like this, right? It would be a little bit.
Thank you.
This is not bad though, all things considered.
Yeah, just pulled it up. Just so it's proud. But if this was a reduced cut, this is smaller than this.
Yep. Yeah, and we often will put putty because, like you said, if it's smaller, there'll be a hard 90. And so we do like to soften that a little bit if possible. With a pipe this size, we can use all 12-inch fabric. If it's a much smaller pipe or a smaller outlet, sometimes we need to use that 6-inch fabric. I'm gonna show you guys. It's a little easier than, because essentially what we're gonna do is we're gonna drape a piece over, and it's gonna get about this third of the weld seam. We're gonna put a piece that's gonna get the center. Then we're gonna put a piece that's gonna get about that third of the weld seam, and then we're gonna seal it this way, and that's gonna be one layer. Yeah, we're one side to the other is what we do. So I would guess it's going to take 3 pieces to cover this weld seam, but it might be 4. It just depends on how they fit.
residue of alles toe. So ja, ek het hulle verwagte en dan het ek aan kaartjie pype. Want ek het my vorige maatskappy het ons gevalle ek het blackleg TV's gemaakt. Ek het hulle klomp ik weet dat het lijkt me niet wat aan die meer cost-effective is, maar so dit is hulle ingryp wat ek
All right, guys, so we're going to mix some 210 saturant. Yep, make sure that one is Perfect. All right. Yeah, you can go ahead and mix it up. Yeah, that'll work much better, actually. We'll wait. We're going to do some more saturating in the afternoon with the tank stuff. Yep. The key is going to be... Excuse me, guys. Gotta get some gloves. So what we're gonna do is, if you want, you can wrap the first couple pieces with me. So we're gonna put the first piece right here, just like a normal wrap, as tight as we can get it to the pipe.
Close, if the welding's there, you want to get close to that or over.
Just as tight as you can get, so right up onto it, like butted right up against it.
Get that angle.
You don't actually want it to angle, so you just want to be butted up as tight as you can. Yeah. And then the second piece will actually angle over the joint. Do you know off the top of your head how many additional layers PCC2 mandates for a T-joint? Is it like 50% more layers? I might have to look it up. So there's one section on PCC2 where, like, when you have different, interruptions in the pipe, they specify like an additional safety factor. And I don't know, I think a T-joint is one of the ones they have. I think Ryan's at 50%. Okay. Okay. I'll mention it and then probably tell them that we can check to see what the actual safety factor is. Because I know that the standard's been updated several times. I think there's a 22 is the latest. Maybe it was 21. Because we were using 2018 for a while. And then there's a newer one than that now. Okay. (2015), yeah. Yeah, of course. I know, it's almost like the people making the rules are the ones that are being, All right, so we want to wrap, yeah, let's wrap that way towards you. Okay, like this? Yeah. All right. If everyone wants to come over, I'm going to kind of show you what we're doing here for a T-joint. Hey guys, if you're saturating, you want to pause for a minute? I'm just going to explain it, and then I'll let you get right back to saturating. As you can see, if we're wrapping down the pipe and we get to a T-joint, the last piece that we're going to put up, I want to butt as close as you can to the T without going up. So you can see that this is laying nice and flat. It went up the tiniest little bit, and that's fine. So we want to butt up as close as we can get to the T-joint. The next piece, our focus is going to be reinforcing the seam on about 1/3 of the seam here. So the next piece is going to go with probably a 4-inch overlap, and we're going to reinforce this part of the seam. Then we're going to put another piece that's going to reinforce the middle third of the seam. A third piece, we're going to reinforce the other end of the seam. And then we're going to tie it in with another piece at the end and a piece on this end going this way. And that would be considered one layer on your T-joint. So if you have a 6-layer system, you need to do that 6 times. But PCC2, which is the governing code, has an additional safety factor required for any sort of interruptions. and I believe that it's a 50% additional layers for an interruption. So what that means is, if it's PCC2 says 6 here, you're going to need 9 layers here. All right? It's tedious. It's a lot of layers. It is what it is. You know, just make sure if you're bidding a job and it's got a T, you're aware of that it does take 50% additional safety factor whenever you're doing something that's an interruption or a non-standard. I will double check on the standard to see, because they've changed it recently, but I believe it's 50% is the additional. So go ahead and saturate 3 more pieces, and then I'll show everyone how we're going to put those 3 pieces, and then I'll let you guys do it on your own. Any questions on what the plan is for the T-joint? That makes sense? Yeah. Yeah. So each piece, we're trying to, it's this weld seam that we're most worried about. Yeah, so we're gonna go about 6 inches onto this on both sides. So typically what I would do is, it depends. If someone is just reinforcing a T, like if you're only reinforcing literally this much area, you know, I would just start on the longer run and then tie it in here and keep going that way. If you were reinforcing this whole pipe and it happened to have a T-joint, that's how you would do it. You would just reinforce, build it down, reinforce the joint, and then you'll terminate, say, here, and then you'll keep going that way on your pipe. So we're going to put the one piece that's going to go here and here. The second piece is going to go centralized in this. The third piece is going to be offset. Then the fourth piece is going to be over there. Yeah. So let's let them saturate out 3 pieces before we wrap them. That way they can watch. So you can just leave it on the table. Do we have enough of the little rolls saturating? We should, I think. What's that?
So is this through or
Yeah.
will the bottom still be liquid?
It's through hard. Yeah. Well, again,
Can we dump it out and see how it looks?
yeah, whatever you want to. The only reason that it would not be, like if there could be a little bit of soft stuff, is if we didn't scrape the sides as well when we were mixing it. But chances are it's going to be, there's not going to be like the bottom layer is still hard. I'm sorry, still soft. Yeah, it's a chemical reaction. And you can tell it created some heat because the bucket's a little distorted and like. You might. So you might need like a rubber mallet, but it might just come out. Oh, look at that. It's not going to break. It's a big block of saturant. It doesn't smell, does it? A little bit. Yeah.
sharing it with us? Or?
Yeah, that's fine. Definitely. Yep. It's definitely more of a training style presentation. I have some other salesy presentations that are more for like client facing that I do. But yeah, absolutely.
Can we get our hands on those?
What I'd like to do is I'm going to do one over at the refinery tomorrow.
Okay.
And so you'll kind of see what I say and some of the things because they're really designed to be talked through, not just read.
I understand.
So there's
No,
like
of
bullet
course,
points
of
that
course,
queue
yes,
up.
yes.
So, but yeah, absolutely.
The refinery in Mossel Bay, which is about 4 hours drive from here. We want to try to meet them by Monday, Tuesday.
Okay.
So,
Awesome.
yeah.
Okay.
So they ran out of gas. Since then, Total has found gas about 40 kilometers away from the platform. We've got a platform I'll show you. So they were tie into the platform again. Now the plant has not been looked after for 3 years.
They didn't mock all of the
They just stopped.
This is why we want to hit them with this.
see what it looks like.
There's going to be a lot of rehabilitation doing this.
This is the perfect answer for it.
Awesome. Yeah, yeah, for sure.
These two plants, so Astron, the one that refinery you saw, they had a big explosion 2.5 years ago.
Yeah, 2020.
2020, February 2020, there was a massive explosion of the furnace. The whole tower fell down on the plant as well. They lost the whole plant.
Wow.
They didn't lose it to, they had to shut down.
Yeah.
And that's been fixed up for the last 2.5 years. So it's just come on there now. So that's why we said there's a big city here. So the plant's a so the brand new plant, we've been focusing on that. The rest of the plant's been grading over the years, neglected.
Yeah.
A lot of facilities there.
Okay.
Obviously a lot of plus, so this is why I wanted to focus on this side.
Okay.
Because this is a prime candidate.
Yep.
And also Petro SA, which is not too far away from the retail plant.
Okay.
Neglected. Where the other plants like Cecil, the big petrochemical, Cecil, Nortrip, and particularly Gauteng,
They're still operational.
They're operational. They're
Yeah.
doing their cycles, shutdowns, turnarounds, and all that. Cycling basis. So
Yeah.
they're replacing parts with regular basis or whatever.
Okay.
Focus on these plants, yeah.
Okay. And just so you know, you can use the same technology on stainless. So there's less prone to corrosion, obviously, with stainless. And we also can use a similar technology on cracks. So we treat cracks differently than corrosion, but both of those are things that we can do. Do you have 3 pieces now? All right. Excuse me, everyone. All right, so what we're going to do, sorry, I'm a little itchy here. We are going to offset and reinforce the first third. We measured this out to have about 6 inches of additional. So this is where it's going to be laid out. We're basically going to, so I want you to go straight around, but give me a second. So you can see this is pretty pliable, this fabric. So all you're going to do is, our focus is this part of the seam. And that's it. So go ahead and go around. And then take this for me. So just make sure your side doesn't have any bubbles. Don't worry about the seam right now. So we shouldn't have to cut it on a 90 like this. If you have like a Y or a different shape, sometimes you do have to actually cut the fabric to make it lay flat. You could do it that way. So what we're going to do is, before we're done, we're going to wrap it here as well, and that's going to hold it all in place. Yeah, but you can see that it stays in place pretty well. Yes, son. And you can see it stays put pretty good. Now, if it's warmer out, it doesn't stay quite as well. If the pipe is hot, it doesn't stay quite as well. But it does stay pretty well like this. And we're going to seal that in with a piece of rounds. We're going to do our third piece, which is going to be the final third of the weld seam. All right. So, do you want to jump in and do it?
Heavier than what you would get on the...
No, you definitely want to make it more like, if you're saturated optimally, it'll be sticky enough. So these were well saturated and they stuck underneath pretty well. If it gets a little drippy, it actually gets harder to work with. Excuse me, guys. Yeah, yeah. So it's nice if you can contour it a little bit. It makes it a little easier. Because what you can see is there's some concaveness to this right at the weld seam. So we would normally put a little putty in the weld seam. Yeah, the key is it's very pliable and workable. So just keep working it until you get it so that it's as tight as possible against the weld seam. Yes. All right, so it takes a little feel on this. So I think if everyone can get a chance who's going to actually be doing this to actually be hands-on. So if you guys already did a couple, why don't you saturate some for us so the next guys can wrap. No, not on a 90. So if it was an irregular elbow, a Y, or it's the same concept.
We had 2 layers here. We put 4 of those. 4 of this process now.
Yeah. So if it doesn't lay down, we have to do a relief cut sometimes. So like if, for instance, if this angle is too sharp and it won't lay down, you would do a cut like right there, and then it will lay down. What I do is each layer, I try to cut in a slightly different angle or direction so that your cuts aren't all on top of each other. Because there's usually several ways that you can cut it to get it to reinforce. The other thing is when we're doing tanks, I'll show you how we do the floor-to-wall joint. You can put just a piece. So if there's some area on the Y that you have to cut each time, like the inside real sharp angle, sometimes what I do is I'll just take like a 12-inch by 12-inch piece and press it so you get continuous fibers that are covering that area that you're cutting. And as long as you wrap over that piece, it's going to be bound in place. So
Just place the piece there, a cavity will be created, but as you wrap over it, it's fine.
yeah, if you just place the piece there, you don't have continuous fibers going around. And, you don't, it's relying on the adhesion strength. But then the continuous fibers you have here are going to hold it in place, essentially. So, but a 90 degree is fairly easy. On an elbow, if you're just going around, if it's a standard elbow, you can just keep doing the bands. You don't have to do any of this fancy stuff. You don't need extra layers. But because this one is an interruption in you can't go full circumferential, that's why you need the additional layers. So there's different techniques of doing this, and I've seen people who use a spiral technique where they kind of like wrap around and go around this way, and that does work with the really thin tape. So if you get a real small diameter pipe, then that is a viable method. I find this to be just way easier and more reliable because we got one layer on everything there. Probably more than one layer on everything, and quickly, yeah. Like it doesn't take that much longer. Yep, keep going. So go ahead and finish this piece and then do the one there. But you could go either way. Yep. See how many pieces we have left. 1, 2, 3, 4, 5.
Every wrap you do, you need to prep the surface. So, for instance, this surface wasn't prepped, we just placed it over for you to demonstrate how to do it, but so we actually need to sand it and then put the adhesive and then only then start wrapping.
Yeah, there's no surface that you don't have to do any prep work. So if it's fiberglass, you can just sand. If it's concrete, we would essentially just clean off any debris. So pressure washing works great on concrete. You could also sand. You could also grit blast, but normally it's a waste to grit blast on concrete. And I would just pressure wash it. But yeah, there's always some surface prep before. To be honest, with this cementitious, I bet it's going to stick pretty well because it's clean.
So is the adhesive necessary to actually get this to
What do
stick?
you say, Ryan? We leave
You
it at
only
the
show
bottom,
us
that's
yesterday
all
to
it
actually
does,
get
and then
familiar
you
with
The which one? The adhesive? I showed it to you to get you familiar with the product.
Is it necessary to
Not on these types of pipes. The other thing you're going to notice is when you wrap, these things are annoying when you're real close. So sometimes I just pull it off of that little roll. So get it started, you might need to pull it off that roll so you can keep it nice and tight. Yeah, that looks good. As long as it can lay flat, then you're in good shape. The other thing with tees, if you have to do 9 layers on this tee, it's hard to build 9 layers wet on the tee. I would cap it off at, probably about 4 layers wet on wet, because it's just going to start, shifting the previous layers, etc. So just keep that in mind, that you don't want to try and do 9 layers wet on wet with a tee. I would wait until it's tacked up and then do the second half of the layers, say tomorrow. Or even overnight is fine. If you use one of our faster saturants, then you could just wait, like you said, 3 hours, and it'll be tacked up enough. All right, so we have, how many more? 4 more pieces? All right, is there anyone that's going to be like a field tech that hasn't got to wrap? All right, come up for the next ones. I'm going to have you wrap just the 3 pieces that are over the weld seam, all right? So go ahead and do 1, 2, 3. Who else wants to wrap? Anyone else didn't get to wrap? You guys both wrapped? He wrapped with me.
It's fine, we can assist.
So hold on. We're not going to do that piece. Let's just start on this piece. That's going to be not in the middle, but 1/3. So about it's gonna end about there. So a little bit that. So you're angled. Go straight. Yep. Yeah, about. So go straight. You're angled. Yep.
Very forgiving.
Yeah, no, it's very fine.
This is to reinforce your seam.
Yes.
So you don't start from this side again, you start from the seam side halfway, it's right, again, as close as the seam as you can.
Yeah. Excuse me, guys. No worries. Thank you. How's it going? Easy? Got the hang of it? Excellent.
Old man with an old pup. And it's got a 2 or 3 millimeter rope. What can I give him? It's K54. 1 meter will last him until he's dead. Just give him to the front. I mean, how much breaking you going to use it? Probably 150 millimeters. Yeah.
Yeah. One more, yeah. And then the last piece we're going to do, I'm going to have you put on the end here to like hold them all in place. Because we only, ideally we would have had an extra one cut, so you could do one here and one there, but we'll be fine. You just put the one on the end. Do we only have 2 of those left, of the yellow things? No, of those yellow things? There's more. Okay. Okay. We just got to clean those after we're done. Normally, like, the next time when you guys do a stocking order, I'll send you a box of 100 of them, and then you'll have plenty, because I don't usually clean them too many times. The resin doesn't really stick very well, but they're soft plastic, so they wear.
That's when they use proper intelligence, not artificial intelligence. That's driven by artificial intelligence. It is. There you go. There you go. There you go with artificial intelligence. No, that's something good. There you go with artificial intelligence.
So after we're done with this, I'm going to have one of you mix up a repair putty. Yeah. Yeah. And then the other person can probably, we'll be done saturating for the morning, so you can probably just take the plastic off. You can see them better, yeah. Sure. So you can still like grind through it or sand through it to get down to the bubble if you really needed to fix it. All of these ones, you know, they're probably too small. Yep. You can still cut through it even with the top coat. Top coat won't stop you. It's pretty thin, so it won't stop you from cutting through. When it's more cured, and you have to use a chisel, and you can chisel it, but you don't want to chisel down. You want to chisel at an angle, so you can just use a hammer and chisel, and that will cut it off effectively. The other thing you can do is use just like a palm sander, and you can sand it down because this is going to be the highest point, and you can usually get to it. You run the risk of like going too deep with a palm sander, so I never use a grinder because it's so aggressive. A grinder can tear right through the carbon fiber. You can wrap over the paint. It's fine because it's also an epoxy, so you don't have to strip the paint the whole way. You might have to sand the paint. It depends on how long the paint's been on. If you're within the overcoat window of the paint, you don't have to do any surface prep on the paint. Then you would, and then you notice it a week later, yeah. So you could sand it down and then sand the entire circumference of the pipe where you're going to wrap. But you don't have to remove 100% of the red. Yeah, you only have to blast if you're going to go down to steel. Now, if all of a sudden there was an issue and there was a leak right here and you need to extend your repair, then you would have to blast because you're going onto new steel. Yeah, then this part you can just sand to tie in. If you're blasting here, you might as well brush blast here. Yeah. Yeah. Yep. No, I would use putty to taper the 8-layer edge, and then you wrap. Yeah, you're going to do about a 6-inch overlap when you tie in. Yeah, well, you're going to putty, so this would be a lot thicker if it was 8 layers, and you'll have like maybe a 30, 40 millimeters of a taper down, and then you'll go an additional 6 inches back. So your first piece would be like here, and it'll include that taper. Yeah, we always want 6 inches to bind to previously existing repair. Yep. Yep. All right, guys, we're gonna switch gears, and we're gonna do some prep for our tank coating that we're gonna do this afternoon. So I'm just gonna put some putty in the seams. So what we're gonna do is we have two 90-degree angles in wood over there. So we want to just set them up somewhere here in this area. We might need to shift some stuff around so that they can film it. But essentially what we're gonna do is we're gonna put the piece of wood down, and we're going to put putty in the corner so that we don't want a 90-degree angle. We're going to basically put a cove in the corner so that it's got a 45. You want that cove, I'll show you how we do it. I actually use these, the orange or the yellow applicators, and I just cut a little diagonal section off of it, and you can use that to get a nice, perfect, clean cove in the corner. So right now, I would definitely get new gloves. but keep on your suits if you want it. So just take your gloves off, get some new gloves, and let's set up those two pieces. He's mixing repair putty. You can go ahead and whenever you're ready. It'll probably take you as long to mix as for us to set up. We are going to use saturate in the afternoon, but by then we can move some of these pipes maybe. And we're only going to have 2 sections because we only have 2 of those. Sure. We're not going to do any saturating until the afternoon. We're going to mix putty, and we're going to putty these wood. So we need to take these wood things and set them up in the floor somewhere. Yeah. It doesn't as long as you have that load transfer medium in there. So the putty will directly transfer the load because it's non-compressible. So like this, we did a fine job. As long as you're tight, like we are here, it's, this is good. Like they did a great job. I mean, it's not that hard. It's pliable. It looks nice. No, I mean, if you have people visit, it's a nice show and tell piece. This was it. You probably have about 4 layers, right? Because if you saw, we basically overlapped almost 50% on each one. No, you can leave it like this. Yeah.
Yeah, I don't want to coat this. We can cut that one off and put it in. This one is not the coat.
So the way this is going to be is we're going to set them down like this. Not next to each other. It's going to be 2 separate stations, essentially. So like one team is going to do the thing on this. They can be next to each other. It doesn't really matter. But like it's not going to be continuous. If that makes sense. And I might turn it this way so they can see it on the video camera. Which camera are we using? Is it this one? That one? That one's fine, whichever direction. Did we clean these ones already, the yellow? Okay. So we're going to need a knife. So essentially what we're going to do is we're going to take this and then we're going to cut the edge about 25 millimeter. And then you're going to put putty in the corner and then you're just going to take this, run it across. You're going to get a nice clean bead. So all we're doing here, guys, we're just prepping these. These are going to be our tank mock-ups. It's where I'm going to show you how to reinforce the floor-to-wall joint and how to lay the carbon fiber on a vertical surface. But the first step is just creating a cove in the corner because we don't want this hard 90-degree angle that you're going to see here when the wall meets the floor of the tank. So essentially, we're going to have about a 1-inch or a 25 millimeter cove that we're going to put in using our repair putty. And by doing it now in the morning, hopefully it will have a chance to tack up before we're actually putting the carbon fiber on, so that it's not as flexible.
So that one, we want it at an angle, or we make it a bit convex.
If it's just a straight 45, it's fine. So that's why I like to take this and just make a cut, and then you put the putty down, and then you just wipe this through, and it's going to look really clean. It's going to be uniform everywhere, so the final product looks more consistent. You already did it? Okay, that'll be fine. You actually go a little bit bigger. We got plenty of putty. Excuse me, guys. Yeah, that'll be good. As long as it's not streaky, it's fine. Yeah.
Is hierdie mic aan? Nee, mens verseker nie wat. Die struktuur wat hierin kan gee. Daai. I like that. Ons is baie baie gesê, jy is verseker om afsny maar net so gaan ons dit. Ek het gesê met hom kyk. Daai kan jy afsny en
So, yeah. So this is a little bigger than you would need, but it's fine. You can't go too big. The bigger, actually, the easier it is to lay the carbon. But, we always have to do some sort of a cove so that there's not a 90-degree angle. You don't have to leave it overnight, but if you can give it a few hours to start to harden, it's easier to lay the carbon. It will look more uniform at the ends. Because right now, if we lay carbon in it when it's totally soft, we're going to have indentations that won't look quite as clean. Yes, you can. This is a little bigger than we would actually cove it in the field. We'd probably make it not half that size, but a little bit smaller. Yeah, you don't need quite that much.
Because I'm just thinking about a big tank inside now.
Yeah.
You get it like a 25 liter.
So you can get a 4-gallon unit, and that's going to be 4 times 3.8 liters, so 12, about 15. That's the biggest unit size that we do is 4-gallon. It's not too bad. You just need a longer stick. You can actually buy like a metal spatula that scrapes the sides effectively. I typically recommend 1-gallon kits, which is twice the size of this. And for like a 50 or 60 foot diameter tank, you'll probably need 10 or 12 of them.
So when are you giving us the expensive tickets ourselves.
Not unless you buy our company.
Yes, but some of them mowers forward.
Yeah, just be careful. You don't want to get too much putty on the floor here. What was that again? How? I've been doing carbon fiber wraps for 8 years. Yeah. Yeah. Well, 2015. Yeah. Early 2015. All right. Now you got to do the same thing on this one. That looks perfect. Yeah. That technique worked really nice when you cut these plastic applicators. Remind me when you order, I get boxes of 100 of those little plastic applicators, and they're like $50. So we'll throw in, a box or two of those because they're just useful tools, a lot better than the stuff that you can just get at the hardware store. I will say for saturating though, you can buy the bigger plastic trowels that have a little handle on it, and those are nice. The notched one is great for underneath, getting the saturant on the table so that you don't have to do the flipping.
The outside corner, so the wrap will go around on the outside. Yeah, like this. So we go again the joint. But that is on the inside. So let's say I want to put my wrap on this one. I make it a round corner.
It is outside also you have a floor, right?
Yeah.
Or a concrete. The concrete. So even there you put the
So this is our last field thing that we're going to do before lunch. So as soon as we're done, we can just kind of clean up the area and get it prepped. I think we do have some extra time before lunch. So what we can do is we can start cutting some carbon fiber for our afternoon session. So what we're going to do with these, we're going to use the 12-inch. We're going to make a 12-inch by 12-inch piece. And that's going to basically cover this angle like that. And we're going to overlap them 50%. So I don't know how long this is. I'm sure we can get a tape measure and we can figure out how many pieces it will take to overlap it. And then we're going to put pieces across this way, essentially. Yeah. So we can measure how long this is. We can get about...
Are we putting what do you call it, underlayer?
The galvanic barrier or the tack coat?
Tack coat.
Yes, we're going to put tack coat on. Yeah, otherwise it'll fall.
So 122.
So what's that in inches?
122 centimeter. So it's like 4 feet.
About 4 feet? Okay. So we can cut pieces to 120. Let's cut 1, 2, 3, 4 at 120. And then what is 12 inches in centimeters? That's 30? Okay. And then we need about, you said this is 4 feet? 5. About 10 that are 30 centimeters. So we're going to cut 10 at 30 centimeters. and 4 at 120 centimeters. So that's going to be, I already times it by 2. So that will do 1 layer on both, essentially. Yeah. This will take 5 of the small ones and 2 of the big ones. So yeah, we can go ahead and cut some of the 12-inch carbon fiber. The key to getting this done efficiently is having somebody in charge of the project that is looking ahead. Like, we could have just stopped, and then in the afternoon we would have had to spend a half an hour cutting before we could start, because there's almost always downtime, right? Like, this isn't a 4-person job. So if you have 2 people doing this, then have the other 2 people, because otherwise they'll sit here and watch.
And I can start cutting.
Yeah, because there's always prep stuff to do.
How long would you say you must leave that now for before you can apply the wrapping?
So you can apply it immediately if you needed to. Like I said, it's for aesthetics. It's going to look really nice if we let it tack up, and that's going to take a couple of hours for it to start to harden so that it won't be so pliable. So in 2 or 3 hours, we're going to be at a point where it's going to stay put like this, and when we put the wrap on, the angle is going to be the same the whole way. We won't have indentations. And
So if you have a big tank, you start from this side all around. When you get to that point, it would be fine to start wrapping around.
But do you also want to send blast the inside of the tank where you're going to wrap?
definitely. And on tanks, you can almost always sandblast because you basically have a containment around.
Full lengthwise or?
I made it a little smaller. This is about 122.
Yeah.
So we're going to go almost full length.
Almost full length, like the 12 inch? 12 inch by like 122?
By 120. I was going to say it'll leave 1 centimeter on each side. So you want both 120 and 30s. Yeah. Yeah. Yes. Yeah. What we're doing is we're going to put, I call it shingles, but we're going to put shingles on the bottom to reinforce the floor-to-wall joint, and then we're going to lay them cross on the top.
Small 12 by 12, like inches.
Yeah. Yeah, we're going to lay them in the corner.
Again with the same.
What we typically do is on the shingles, I'll usually do a 50% overlap, so I get 2 layers, and then I'll do 2 layers around the tank because none of it's governed by PCC2 anymore. When you're doing it on the tanks, it's a totally separate, almost like we do our own engineering assessment each tank, so it's custom for each tank.
12 inch by 12 inch. You can take a 12 inch.
Daar's die challenge.
surface prep kan kry en ek wil dit binne in 'n tank. Die tank het altyd soms op 'n nisje daarby gaan altyd iets wees, daai tank gaan nooit skoon wees. So kan jy binne 'n tank ja, kan sandblast, dis seker nie so nee, Brussel het dit
Kyk, as Sakkie nou hier was nou fucking expert geskep.
Sakkie nou.
Ja, Sakkie, hy sal 'n expert gewees het. Hoekom het jy nie vir geantwoord? Dis hy. Ek het daar. Ja, lê onder die tafel.
All right, guys. Looks good. This is the last thing that we're going to do before lunch, so go ahead and clean up. You can take your suits off. Um, we will be doing more application after lunch, so if your suit's fairly clean, you can keep it. I don't know, that's up to you. But we are going to be back in the classroom doing a presentation after lunch, and then we'll come back down here after, and we're going to do the wrapping on these. Sure.
So we're working on angles and all of that. So saying, I saw on the one quote, if you've got a hole through there, how do you patch it? Because I only saw the one piece of.
You mean like a manway, essentially, or like a...
Say there's a hole, or there's something that they're worried about that might burst through.
Okay.
A temp or
So you corroded maybe the
on the
whole thickness.
inside. And you just got that patch. Do you patch it on the outside? Can you just use the sheeting on the outside, or how do you?
So we don't typically patch on the outside because when you're patching it on the inside, the force of the pressure pushes it into the wall. If you could do a temporary patch on the outside. I've seen people do that, but it's a lot harder. You really need great adhesion and bond strength to get it to patch on the outside. So we typically patch on the inside.
So essentially, when they drain the tank, they've got the access to there to fix it.
Yeah.
Then okay.
Normally when we're doing that patching, it's because they were just planning on doing a coating on the tank. But they got in and they were sandblasting the tank and they realized that there was a hole that they didn't expect. So instead of welding a plate, it's another option where you can just do a patch before you coat it, because then you don't have to do more
So that means
blasting.
the tank was drained, so you had the carbon on the inside and on the outside. You do it over there.
So we just do the inside. We don't even do it on the outside.
Okay.
Because normally,
The photo stipulates that it's on the outside. What shows?
on the outside, if there was a through wall, as you were blasting, you might be able to see a tiny bit of carbon fiber, which is fine. I would have them just paint it if they didn't want to see the carbon fiber. But in my experience, a lot of the holes are either on the floor or right in this joint where the floor meets the wall, so you really can't see it from the outside.
Okay. So you won't recommend if there's a hole, not a hole, but integrity thread, that they're thinning on the wall and they can't drain. It's not going to mean anything to put that thing on the outside.
So you can reinforce tanks from the outside, but you'd have to go the whole way around if you want to reinforce the hoop strength of the wall. But the reality is, if it's internal corrosion and you're reinforcing the tank from the outside, it's going to be a temporary repair, and you risk catastrophic failure if it keeps corroding away from the inside. If you do an internal repair, you're stopping the corrosion. So you're going to keep the tank at the state it's in. So most of the time we do tank repairs internally. Every now and then there's a reason why, and we can do it externally.
Okay.
Like the one that I showed you, you might have seen it where we did the tank externally. That was a weld seam issue, a selective weld seam failure. So the tank as a whole was in decent shape, but they'd had some weld seam failures. So we could reinforce it just from the outside.
What's the length of one of those rolls?
These rolls over here,
Yeah.
Uh,
or the maximum length on a roll you got.
50 yards. So that's maybe 45 meters.
Okay, so obviously, yeah, but the thing is, if you have a really large pipe, will you actually be able to put the sections over one another around the pipe, or the circumference of the pipe, or should it be one piece?
The longest pipe that I've done in a single piece was a 10-foot diameter pipe. So that's about as wide as this thing is. Yeah, it's a pretty big pipe. And we can go all the way around on a 10-foot diameter pipe. On a tank, so we've done like 60-foot diameter tanks, we can't go the whole way around. It's just not practical. So we have to cut those pieces. And what we'll do is we'll go, say on the tank internal, 15 feet pieces. So if the seams are, right here, next time we'll offset the seam by 50%. So you'll do When we do tanks, we do 2 layers at a time as well. So we'll do a 50% overlap. So if you want to build 6 layers, you basically have to do it 3 separate applications on the tank wall to build 6 layers. So basically the first double layer, if your seams are here, on your next double layer, you'll offset it by half. And then you go back to the original on the third double layer. Yeah, just it's the same concept with the pipe where we just offset where our seams are.
If there's a leg, it doesn't follow straight through. First, it has to creep to the one side to get through.
Yeah.
Welding, you also do the weak point
All right. All right, if anyone's online, we are going to pause for lunch and we will start up again at 1 o'clock.
Okay, I've got all of the guys over there. Would an ID number of mine, a copy of his ID be okay? Send that to me tomorrow. Yeah. Yeah, but it's holiday time in the DRC, so I can't get it today. So you'll send it to me tomorrow. Right, it's tomorrow. One day. Yeah, I'm telling you, it must be the mountains. Okay, big stuff. Okay, big stuff. Bye.
Welkom, meneer General.
This one that I'm going to show you is square, so it's really not applicable. All right, everyone. It's 1 o'clock, so we're going to start up the afternoon session. Hopefully everyone enjoyed lunch. Thank you for lunch. Very good. Any questions before we switch gears and we switch from pipe reinforcement to tanks and other reinforcement? No? All right, sounds good. This is the first time you guys haven't had any questions.
That's not good.
So, so I taught you about PCC2 a little bit. You know, it's a guiding standard for pipe reinforcement. It's also a standard for pressurized vessels, but it is not a standard for tanks. There is an API standard, 652, for lining of above-ground petroleum storage tanks. Also, API 653 has a specific annex, Annex J, which deals with reinforcing the shell of oil storage tanks. But neither of them are nearly as comprehensive as PCC2. Both of them leave a lot to be desired. It doesn't mean that we can't reinforce tanks. We can. There's just not a really comprehensive standard that we can stick to. So PCC2 has thought about all the different issues we might face. You know, what do you do when there's a T-joint? What do you do when there's a reducer? What do you do with a flange? That's all built into the code. These codes are not nearly so robust. In fact, 652 doesn't make any differentiation between using a glass fiber or a carbon fiber. Just lump all fiber reinforced as one thing, you know, a thick film fiber reinforced. The 653, which is for structural reinforcement, does actually differentiate between different materials. But again, it's only for the shell, and there's definitely some limitations there. So the question is, a customer has a tank, they want to reinforce it. How do we tell them how many layers and how we're going to reinforce it? What I'm showing you here is something called finite element analysis. This is a computer simulation of a tank. So we basically took a tank. This was a square or rectangular tank. And then we reduced the wall thickness to whatever their maximum corrosion depth was. So say 50% wall thickness. And then we add layers of composite. So this one has 2 layers of carbon fiber and 50% wall loss. And you know, I'm not an expert on FEA, so I'm going to explain this as best I can. Obviously, the red spots are bad. That's high stress areas. So as we add more layers, so this is 4 layers, we get a lot less stress on the tank, or a lot less areas where you're really close to your safety factor. As we continue to increase it up to 6 layers, even less stresses on the tank. So the problem is, this isn't black and white. Like, should this be 4 layers? You know, should it be 6 layers? I don't know, what's the safety factor that you really need? It's not specified anywhere. So, but this gives us a lot of information. Like clearly 2 layers is not going to do the trick.
After you've run these simulations, did you actually test it on vessels or not?
No, it's also very hard to do live testing on tanks, right? We've done dozens and dozens, maybe hundreds of tests on pipes, because we can get a steel pipe, we can pressurize it. It's pretty easy.
And it fits in a warehouse.
Exactly. So no, we haven't done any live tests. We've done tests on pipes, and we base it on the tensile strength and the modulus, which we do tests to determine on the actual material. But we just put those theoretical properties, or those physical properties, into this theoretical calculation. So this is a useful tool. It's engineering justification is what it's providing, so that someone can say, you know, we analyzed it, and this is our reason for going with this number of layers. Now, the problem that we often face is there's a cost behind doing finite element analysis. It's not free. I can't do it internally. Like the PCC2 calculations are easy. You know, I can do it, your engineers can do it. This is a little more comprehensive. So if someone wants this, you know, the costs can range anywhere from $3,000 to $10,000 US to get this ready to go. So what I recommend, if at all possible, if a client knows they're having issues with a tank, you know, if they're going to sole source it, you know, we'll include this as part of the price. But mostly they won't do that because they want to know how much it's going to cost. So oftentimes we'll try and get them to do like a pre-assessment, like plan it out. No matter what you're going to do, this will be useful information to see whether or not, you know, you can use composite to reinforce your tank. So, you know, it's something to think about as we get more and more finite element analysis calculations on tanks. It's easier to estimate, because that's the other thing we can do is just what we normally do on tanks is give them our best guess, you know, from our experience, and say, all right, we think it's going to be 4 layers, and we'll budget it at 4 layers, and we'll include the finite element analysis in that budget, so the final deliverable will have the FEA analysis. But if it's actually 5 layers, it's going to cost a little bit more. That's another way we've done it in the past.
Excuse me, was this done on the inside or outside of the tank?
Inside. So almost all of our tank reinforcements are going to be internal. And the reason for that is if you reinforce externally, you'll structurally reinforce your tank. But you're not stopping the degradation mechanism, which is typically either erosion or corrosion internally. If it was external corrosion, then you can permanently repair the tank from the outside. But if you have internal corrosion and you repair the tank from the outside, after X number of years, you risk catastrophic failure of that tank as you continue to corrode away the metal. So, I'm going to talk you through a couple of tanks where we did some repairs. And then at the end, we're going to talk through the process of actually installing the repair. So first, I'm going to kind of show you what we've done where, and then we'll go through the actual process. So this is a 90-foot diameter water storage tank. It was only 12 years old, but when they installed this tank, it was supposed to have a coating. They just never put a coating on it. They put it in service. They checked it 10 years later, and they had a major issue. They had lost half their steel. You can see some pretty significant corrosion on the wall. We rebuilt the bottom 10 feet with 4 layers. There's always more pressure on the bottom of a tank, so it's pretty typical that as we go up, we can reduce the number of layers. And then 3 layers on the top. A couple of things to keep in mind. I talked to you guys about galvanic barriers. On a tank, we actually use the epoxy, that top coat that you just put on, as the galvanic barrier. Putting fiber on a tank is time intensive and labor intensive. Spraying the galvanic barrier with a spray applied system is way, way faster. So for tank internals, if you get to a big tank, especially if you're doing the sidewalls and the ceiling, using the spray applied galvanic barrier saves you one hand applied layer, and it can actually save a lot of money. And this works great as a galvanic barrier also.
The reason why you're running horizontally and not vertically with a wrap, is it because the installation easier? Or?
It's because primarily we're trying to reinforce the hoop strengths. So we want to orient as much fiber horizontally. This area where you see it running vertically is an extra reinforcement that we add whenever there's an interruption in the tank. So this is another tank. It was an oily water or water sand separator or something like that. And it had really severe pitting from a microbially induced corrosion. This particular tank, an inspector had come in and they got an engineering firm and they basically said, you need a new tank. And the facility was like, we can't get this tank out and we can't get a new tank in. Like, replacement is not an option. So they came to us and we were like, listen, we can just build you a new tank inside your existing tank. And they said, that sounds a lot better than replacement. So we went ahead and did that. It was a fairly small tank, maybe 10-foot diameter, maybe a little bit less than that. But 4 layers of carbon fiber and 1 layer of fiberglass. And then because there was an agitator in here and it had some abrasion, we had to put a ceramic reinforced epoxy, which is what you see here, as the top coat.
So if you're in the food industry and you've got a tank that's not food but like sauces and stuff like that, is it safe for the industry, for the food industry?
Yeah, one of your colleagues asked me about food as well. Our composites are FDA approved for food contact. Approved is the wrong word. We comply with the FDA regulations for food contact. So if complying with the US FDA regulations is sufficient here, that I can't tell you. But if it is, then yes, you can be in food contact. You cannot go in potable water contact, though, with our system. So if it's drinking water, we don't line drinking water. At some point in the future, we might get our system tested and accredited for drinking water, but right now it's just not a market that we go after. And the certification costs about $10,000 a year, every year, just to maintain. So we're not selling enough into that, but FDA gives us a list of chemicals that you're allowed to use, essentially.
Oh, so if it's on the outside of the pipe, it's fine, or the outside of the tank, or so, but on the inside of the water, it's
Yes, yeah. And if it's like raw water, processed water, fire water, all that stuff is fine. It's just drinking water. So, we've talked about carbon fiber on pipes. We talked a little bit about thermal cycling and things like that on pipes. Thermal cycling is even more of an issue on tanks, especially if they're made of aluminum. We can have permanent repairs in carbon steel tanks. I know this is a very wordy slide, so I'm just going to give you the gist of it. We don't want to do carbon fiber repairs in aluminum tanks that have thermal cycling. It's just not compatible. So steel tank, good. Aluminum tank, not good. Don't do carbon fiber repairs. If it's a fixed temperature aluminum tank, then it's fine. We can do carbon fiber repairs. So we adhere well. It's just the stresses from thermal cycling will eventually cause it to delaminate. But that's not true on carbon steel. So here's another tank that we reinforced. This was a fuel oil storage tank. This was a smaller tank, so we had to do 2 layers only. This is what we call tank enhancement. So sometimes we build a structurally independent tank, and other times they've done UT analysis, so they know how much wall thickness they have left on their tank. So we can just add to the strength of the existing tank. So that's why we could go with only 2 layers here. So this is not a structurally independent tank. We were just enhancing it. This was a 95% sulfuric acid overflow tank. They actually had acid brick on the bottom. That's why you see this kind of lip. And I guess their sulfuric acid had gotten over the point where the acid brick was, and it had totally eaten up the concrete walls that they had. Why they had concrete walls on a sulfuric acid overflow tank, I don't know. I didn't design it. But we were able to use a Novolac-based epoxy that's resistant to up to 98% sulfuric acid, accompanied with our carbon fiber. We do top coat this as well. Whenever we do a tank internal, we always put a top coat. That's the one area where you'll never leave carbon fiber bare. So here we did 2 layers of our Novolac epoxy top coat to ensure that we had a pinhole-free and fully protected area. One big advantage of using carbon fiber in this application, so this is a concrete tank. Concrete, as we all know, cracks as it ages and things shift and move. The carbon is so strong that if the concrete cracks, the carbon will not crack. If you just epoxy coated this, because the epoxy by itself can withstand the exposure conditions here. But as soon as that concrete cracks, the epoxy will crack. And you get sulfuric acid in it just one time after that concrete cracked, it's going to eat a hole right through the concrete. So that's why we use a carbon fiber reinforcement. They don't have to do any maintenance. They don't have to check for cracks. This will give them a long-term maintenance-free solution. It's great for secondary containment as well, but primarily only for acid service. If it's secondary containment for like a hydrocarbon, a crack won't really immediately eat through the concrete. So the stakes are a little bit lower, and oftentimes they won't mess with using the added expense of carbon fiber. So full tank reinforcement is another option. I told you we almost never do externals on tanks, but occasionally we do, and this is one example when we did. They had specific degradation to their weld seam. They didn't have enough time during the outage to be able to fix the weld seam properly, so all we were able to do was get inside the tank, diagnose the issue with the weld seam, and then we rebuilt the tank from the outside. So to do this, we had to assume that the tank, at least the weld seams, were going to fail. So as we designed this tank, we didn't assume that we were going to have any strength from the weld seams. So we designed a structurally independent tank. It was a fairly small tank, which made a big difference, because if you get to a real big tank, the compressive load is really the thing that's going to make the carbon fiber a whole lot thicker. The burst pressure on these tanks, because they're very low pressure, is usually not a big factor for the carbon fiber. Just some pictures after it was top coated.
Did you do the full tank?
Yes. Now this was a cylindrical tank, and I mean, it wouldn't fit in this office, but just barely. It was just a little bit bigger than this room. So it wasn't that big of a tank, but we did the full tank. End bells.
And with your supports there at the bottom, what would you do there?
Yeah, so great question. They were metal, the supports.
Okay.
So what we actually did was we went down onto the support and just tied into the support. I showed you this the other day, but it's in this presentation for a tank roof repair. Another opportunity where we did external. This was really just leak sealing is what we were trying to do here. So HCl is volatile. It has strong odor to it. They wanted to mitigate the odor, so they had a neutralization system, but it doesn't work if you have holes all over the top of your tank. So that's all we were doing here, was ensuring that the HCl went into the neutralization, not out into the plant. and this was the final coated version. So we've had various reasons why we've reinforced tanks. Oftentimes it's internal corrosion. This particular one, we think something maybe washed away, or the pad wasn't poured correctly or something, but it cracked this tank right in the middle.
With a weld or not on a weld?
That's a good question. I'm not sure. It doesn't seem to be on a weld. I wasn't there when they took this picture. But what we did was we basically, this was an aluminum tank. And so they didn't want to do aluminum welding, because I guess it takes a long time. Again, I'm not an expert. But you can reinforce just the bottom using this carbon fiber technique. Sometimes if the issue goes up a little higher, we can reinforce a little higher up the sidewalls. So in some cases we go, 4 feet or 6 feet up, and in other cases we go just 1 foot up. It really just depends on the service, and we'll do an inspection. The cost differential to go a few extra feet is not very high. When you have to build scaffolding, that obviously increases the cost a lot. So going from 1 foot to 6 feet really is a minimal increase in cost. So this plant just decided to go as high as we could practically. They probably didn't really need it, but. Another thing we were talking about was external patches. So external patches on tanks are considered temporary repair options. So I said we don't do it. That's not entirely true. Occasionally we do an external repair, but we don't consider those permanent. Now, a temporary repair option can be 2 or 3 years, but to properly repair this permanently, really you should get inside the tank and do a patch from the inside. But if they just need a couple of years, a year, whatever, you can do repairs from the outside as well. But on this particular repair, they grit blasted it. It's really important if you do an external repair that you get really good surface profiles, so you get good adhesion. Another thing that I mentioned was patching, just small patches on tanks. This is not structural. This is a leak stop is all it is, right? So this is stopping a pinhole leak. It's not adding any structural strength to the tank. We don't have enough carbon fiber here to add structural strength. This is an option instead of welding a patch. So you can see these tanks were blasted, and someone was going to coat this tank. And when they got in there to coat it, they realized they had holes, and you can't just coat over a hole. So typically, you would weld a new plate on it. But if you weld a new plate on it, you have to then grit blast that plate to get your coating to stick properly. And so that was a big cleanup issue. They didn't want to, they'd already cleaned up. They didn't want to grit blast and have to clean all that dust out of that tank again. So using this carbon fiber patch, you can just put that on and then coat right over it, just like you normally would. So I don't know whether that'll ever come up for you guys because you don't really do coatings, but if it does, it's a good tool to prevent that extra cleanup step. So some keys to tank reinforcement, how many layers are required? Does the end user have the data that we can actually analyze and say we can do a tank enhancement? Or do they not have the data, at which point we have to assume that, the tank has, essentially through-wall failures? It just depends. Some customers will have that data. A lot of them will not. If the data is available, it can absolutely save you money on this reinforcement option. Certain things, we can't handle. Temperature cycling on aluminum tanks. Certain chemical exposures we don't recommend doing tank reinforcements on. Tanks we always want to grit blast. If they say you can't grit blast for some reason, walk away. We don't want to have a failure on our hands. We grit blast tanks, especially when you're doing a partial. Theoretically, if you do the full tank, and it's structurally independent, you shouldn't need to grit blast. we still like to grit blast because the last thing that we want is, some of the liquid to get behind and in between our carbon fiber and the tank and corrode holes and create issues. So we always grit blast on tanks, and if they can't, The other thing is if there's erosion, so corrosion, we can completely stop corrosion. But if there's wear or erosion, it's not going to be a permanent repair, right? Carbon fiber does not have great abrasion resistance. We can put a ceramic system on top of it, so if it's moderate wear, we can absolutely do reinforcement options there. But Kevlar is better, and fiberglass is actually also better. If the reinforcement is structural, though, the carbon is a much better option to create the structural reinforcement. So we can do things like use layers of carbon for structure and then put Kevlar on top of it. But the ceramic epoxy wears a lot better. It's just when you do that approach, every 5 years they need to inspect it. And typically what we'll do is we'll put multiple layers of the ceramic epoxy, and the bottom layer will be red. So when you see the red layer through, you know you need to plan your repair, or at least another application of the coating. But just for corrosion, that's not an issue at all, but for wear or erosion. So again, just to reiterate, these are the 4 types of tank reinforcement options that we have. Spot repair, a sectional repair where we're only doing one part. A sectional repair could be just the wall. There is times when we only reinforce the wall. A full tank enhancement where we're rebuilding the structural strength of the existing steel, and then a structurally independent tank where we're just building a new tank out of carbon fiber. So those are kind of our 4 options that we have. This was just a graphic that we made for a brochure. As I look at it, it's kind of confusing. But we'll teach you what each of these steps are and how we reinforce as we get into the practical application portion. So surface preparation, like I said, grit blasting is really what we do. We always use some sort of a primer. It's usually a galvanic barrier as well.
Yes, I just want to know, if you're doing the inside of a tank, you start on the walls first, putting your corner in and working upwards, and then lastly you do your bottom floor. Reason asking is, when can you put pressure or weight onto your carbon? Only 3 days or 50 days?
So,
if you need to build scaffold.
yeah, we would typically do the walls and ceiling first. You're right, so that your scaffold is in first,
Yes.
and then you take your scaffold out and you do the floor and you tie it into the wall.
Do it in the right order, is what you get at.
Yeah, you do it in the right order. You can fill this tank, usually it's 2 or 3 days after you're done with the application. So it can take load at that point. As far as putting scaffolding on top of the carbon fiber, I never recommend that. I mean, I'm sure that you could do it if they had to get in for inspections, but during our application, I would never do the floor first and then build scaffold on top of the floor to do the sidewalls, because as we know, scaffolding can shift around a little bit. The guys putting the scaffolding together are not careful. They bang it around. So yeah, I would definitely, if you're ever doing tanks, ensure that you do the floor last. And even when you're going to do that floor, look for areas in the wall where they banged with the scaffolding as they were taking it out. So if we have pitting internally, it's much harder to put our material on a heavily pitted surface. So we like to do our best to fill the pitting in. If the entire tank is pitted, sometimes it's not practical to trowel on that putty over the entire tank. We have a higher build spray applied coating. It will reduce the pitting. It won't completely eliminate it. It'll cover it all, and a little bit of it will be mirrored out, but it makes it a lot easier to put on. So there's a couple of options there if there is widespread pitting. The first thing, now this is looking at, working from the bottom up on this particular tank, we were just doing the floor to wall joint and then the wall all the way up. So we didn't do the floor itself. The first thing we do is reinforce that floor to wall joint. I call these carbon fiber shingles. You can see we're working our way around the circumference of the tank with these. Those are 1 foot by 1 foot, or like 30 centimeters by 30 centimeter squares. We put them in with a 50% overlap, so we're going to get 2 layers as you go around the tank. And we're going to actually do this live downstairs. That's why we coved this corner. After that, we put up our bands that are going to go around the shell of the tank, or the tank wall. You can see we have a 12-inch band at the bottom, and then a 25-inch band that they're putting in now. We always work our way from the bottom up on tanks, and there's a reason for that. I'll show you with the tack coat when we're downstairs. You can kind of see the tack coat that's here. It's kind of hard to tell, but the gloss is a little different in the bottom part of this picture than up here. The tack coat is clear. I've been thinking maybe I should put a little pigment in it so it's easier to tell where it is. But the tack coat's what holds this horizontal or vertically against the wall. So we put the tack coat on immediately prior to doing any of this vertical application. As we go up the tank, we're going to do a 50% overlap plus a little bit, because we want to make sure we go over our 50%, because we're essentially getting 2 layers on at a time. So if this tank requires 4 layers, we're going to do this process from basically floor to ceiling twice with a 50% overlap. So 1 application gets you 2 layers. We only do 1 application at a time. We can't do wet on wet for multiple layers, so we can basically get 2 layers on. Then you have to wait for it to cure, then you get your next 2 layers on. For large diameter tanks, it can take several days to get the carbon fiber installed, so it's not usually an issue if you can only do 2 at a time. And you can see they just work their way up. So, and each time it's that 50% overlap. So that was a tank where we only did the walls. Now, if you're doing a floor and floor to wall joint, it's very similar, but a little bit different. You're going to have these bands that are going across the floor, right? We're going to do a 50% overlap on those bands, so we get 2 layers on the floor at a time. You can't go wet on the floor because you need to walk on it. So basically you need to let it cure in between. And the way we'll do it is we'll work from both sides into the middle. And so your last piece, you essentially are working your way out of the tank as you're putting it down. So again, 50% overlap. When this band hits the wall of a cylindrical tank, it's going to go up on the wall. So, and we want it to go up on the wall a little bit. And it's going to be uneven. So, right in the middle, it might go up 1 inch. And then as this tank curves, it's going to go up 3, 4, maybe even 6 inches, depending on the diameter. And that's fine. What we want to do is have it go up on the wall. We've already reinforced the wall-to-floor joint with those shingles, right? So what we want to do is make sure that we get the entire floor. We go up a little bit on the wall, but we don't want to go up past where our 1 foot band is going to go around, or it just looks like crap. So you could go up higher, but we try to keep it between 1 and 6 inches off the sidewall. Switching topics before we go downstairs, I just kind of added this in because I thought it would be useful information for the team. We've talked about reinforcing pipes. We've talked about reinforcing tanks. We also do infrastructure reinforcement like beams, columns, concrete pads, etc. So we're not going to do any hands-on on this. I'm just going to kind of show you. If this ever comes up, it's a solution that we can help you with. I don't know that we have any immediate applications here with you guys with this, but anyways, I thought it'd be good to know. So you can see some of the different types of repairs that we do here. column confinement and reinforcement, if people have to cut openings in concrete and they had designed it with the rebar and afterwards they had to make an alteration, carbon fiber is a great tool to be able to reinforce that concrete when you had to remove or cut rebar. Or if you have like post-tensioning wires that fail on concrete, pretty common on like parking decks and things like that, carbon fiber is another solution of building in the strength that you lost when that post-tensioning rod failed. So you can see beam reinforcement is something that's been done with carbon fiber for almost a decade now. What we're doing with this beam reinforcement, we're not actually adding compressive strength to the beam. Concrete doesn't stick very well to concrete. So if you take a concrete column and it's starting to spall and you're losing concrete, you're losing the compressive strength. Concrete's got great compressive strength. But if you put more concrete on and it gets compressed, that concrete's just going to fall off because it doesn't bond well enough. So what we do, it's called shear confinement. So we're going to refill that area and the carbon fiber is going to wrap around it. Now the concrete has nowhere to go. So it can take that compressive load now because it's confined and it can't fail out because the concrete's so strong in hoop. So it's kind of a unique way, but it's a good way of reinforcing columns, square columns or circular columns. Beams, we can also do reinforcement of beams. So if you have an issue with a beam, whether it's cracks, whether it's the load is different from when it was originally designed. We have several projects that we did out in the Houston area where they had designed it to a certain safety factor, and then with the hurricanes someone decided they need to increase that safety factor. The beams are already in place in these buildings. So this is a pretty interesting way of basically making that beam stronger than the original design. There's also something called carbon fiber laminate strips, and these are pre-cured. It kind of looks like a carbon fiber 2x4, but it's a little bit thinner. And you glue it onto the ceiling, and they're very stiff. You can get a lot of reinforcement in a single layer. We haven't done much work with these, but it is an option in certain cases. This is an actual project that we did out in Houston where they had to reinforce this beam. The first step that we did, because we were reinforcing the bending moment, that means like they didn't want it to buckle down. So we put carbon fiber strips, I think 10 layers on the bottom of this beam. Then the bond strength to concrete, it's only about 300 to 500 psi. So there's not that much bond strength because concrete's not that strong. So what we did next was, after all the bottom layers were on, we did kind of a similar concept to the shear confinement. We wrapped it around. Now we're taking advantage of the strength of the carbon, which is really strong, locking that bottom reinforcement panel in place. And we went across and did this entire beam, and that was able to give them the additional safety factor that they needed because of the increased requirements. Similarly, this was a concrete pad, and it had cracked. A design engineer had specified carbon fiber along with a steel column. So after putting carbon fiber on, they actually had to put a column all the way across this. When I went in and I was talking to the end user, I told him, like, you could have just put 10 layers of carbon instead of one layer of carbon and a steel beam. But the engineer had already decided, and this was a municipality, so they didn't want to mess with it. But we can do reinforcement from the bottom side of cracks in concrete as well. These are just more laminate strips. One thing that's worthy of note on the laminate strips, we're basically gluing them to the top. Again, that doesn't stick that well to concrete, 300 to 500 psi. So we actually put epoxy anchors in the ends. We basically drill through it, drill into the concrete, and you inject epoxy and put an anchoring bolt. and that's a way we get some additional adhesion into the concrete. And it's mandatory when you use these pre-cured beams. All right, that is, I think, all for our theoretical. What we're going to do now is we're going to go downstairs, we're going to get suited up, we're going to reinforce the floor-to-wall tank mock-ups that we made, and I believe that is all that we have left to do. So any questions as we're still in this theoretical phase?
On the bottom where you cut the, what's it, the foot, 1 foot by 1 foot.
Yep.
Is that a set standard? Or reason why I'm asking is it because of the angle of the tank that you're cutting it into that small pieces so you can get more easily the bend in it?
Yeah, a great question. I'll answer it. It's kind of a two-part question. The standard does not say how we need to reinforce that floor-to-wall joint. The shingle approach was a design that we came up with. The standard really doesn't say anything about it on how to reinforce the floor-to-wall joint. The reason why we don't just do one band all the way around is because of the cylindrical nature of most of the tanks. So if you did one band, it would not sit flush. If it was a rectangular tank, you could just do a band, like a long band, and it would go, 50-50 on the wall and on the floor. If we try that on a cylindrical tank, it looks terrible. It's not even. So that is why we do the 1 foot squares.
Obviously, the smaller the tank, the smaller the squares.
Yeah, 1 foot works for anything. You could use bigger squares on a really big tank. It's kind of a pain to put those 1 foot squares, but it is what it is. They saturate really fast, and since saturating is usually our rate limiting step, you can get like 10 of them saturated, bring them in, and then by the time they got those 10 on, the next 10 are usually ready. So it goes faster than you'd think.
Not off the topic of tanks now on piping. On in-service line on temperature, what maximum temperature can you apply this wrapping?
So the maximum surface temperature that we have applied was about 190 F. So as we talked yesterday, that's like 90 C, somewhere around there. As you noticed, you have to touch the pipe to be able to install our system.
And you don't want it to get too dry too quickly as well.
At 90 C, the material was cured and hard in between 15 and 20 minutes. So you really did not have much time to move it around. So yeah, it was a very challenging application when we were doing it that hot. But it was possible. The performance, the material performs great if it's installed right. It's just much harder to install when it's hot.
So that particular one at Ashford was much higher. It was like 200 and something degrees where they applied to that.
Yeah, so epoxies have a thermal degradation temperature of between 425 and 450 F. So in centigrade, it's probably 200, 220. There's no way that their system can withstand 280. It's going to thermally degrade. And it's going to start from the inside, where the temperature is coming from.
So 425 is 220.
220.
So that's where around about that pipe was, operated.
But I think, didn't we have a chat with Craig and the temperature was a lot higher? That was probably one of the factors that they didn't take into account. It was too high for the wrap.
What would it look like then if that happens, if the temperature's too high?
So what it will look like is the carbon will just lose all of its bond strength. And essentially you'll get an air gap as the carbon chars. You'll smell it. You'll have the smell of like, it's hard to describe, but a chemically burning smell. And if you cut it off, I don't know that I would be able to say that's thermal degradation or not. But from the smell and the fact that it will lose the adhesion, you'll be able to just peel it away.
And will the product become brittle as well?
Not necessarily. The carbon won't degrade. Carbon fiber can go to thousands of degrees, and most of the strength is from the carbon. But if you burn away all of the resin, the carbon is not going to be, it's useless. Yeah. So it depends on how much of the resin was burned away. It could get brittle. It's going to fully cure out the resin as much as it possibly can, which will be its hardest state, and it might be slightly brittle, but it's normally carbon reinforced composites are really not brittle at all. Any more questions? All right. So let's take a few minutes. We'll go downstairs, get suited up. We're going to be doing some saturation, and we'll do those tank mock-ups.
En nou, maar al daai het is nog net so opgesit.
Ja, daai is mos net 2 lank.
Ja.
So eintlik as jy weer moet doen is nou 'n derde laag. Hoe sê jy soet
En dan kan jy
Tromme, dis tromme. Tromme.
die droog is daai doen. Pak nie.
Thanks man. Yeah, you too, man.
Dat moet bly die vuur geplak.
Why can't I go to Limbashi on the 12th of June? You're not my mother. Okay. Oscar, what the rental is on a Land Rover to
So that's on the Sunday. And there's only one flight, eh? And let me guess, it's 9 in the morning.
and a Land Rover.
You know I'm a married man, eh? I sometimes like waking up next to my wife. Yeah. She probably needs the break. It is what it is.
Die droog daarom.
No, I have to book a hotel on the 11th because I already found the mine on the 12th. Yeah. Okay.
So full plane?
Yeah, 100%. I'll fly out on the Sunday.
I've got it in my hair a few times.
Okay. Picked up.
Doing those overhead applications.
I can imagine, yeah.
Don't we want to ask Alex if we can move the training one day?
Friday's a holiday.
Yeah, but what I'm
Flying
saying,
on the Monday, do the training on the Tuesday.
yeah, but what I'm saying is, can't we fly you out on the Sunday? That was probably one ever.
Yeah, I'm going to fly out on the Sunday.
Yeah, but only to Lumumbashi.
Limbashi, yeah. Then I'm going to have to spend the night in a hotel. And then Monday catch the flight in.
I don't see a problem staying over and done in
All right, guys.
DRC.
Not at
Sounds
all.
amazing.
It sounds
A little bit of John Grisham and I'll be sorted.
Okay. There's not too many pieces that you're gonna do. Were you gonna put it here in the middle? Oh yeah, you can put it right there actually. Yeah, go ahead and put it right there. But if you put it tight against this wall, because you don't need to access both sides, you can put the table right here, and it won't block the camera. All right, so what we're gonna do here right now is we're going to do the shingles on the bottom of this like I showed you, and then we're going to put a couple pieces across as well. Now that I think about it, we actually need to cut one 25-inch wide piece at 120 centimeters per. So before we start, we can start mixing, and let's also cut two 25-inch by 120 centimeter pieces. All these pieces that we've already cut, we can just put into a box somewhere so that, because we're going to use that as our saturation table. So if we have a clean box, that would be great. If not, we can find one. I think we still have more boxes over there. It was nice because we could see it when it was that way. Yeah, make sure at the end, you're right, let's cut some extra pieces. We might as well cut while it's right here. Will a 2 foot by 1 foot sample be big enough, do you think? It'll be like, I don't know how big we can.
I think 3 foot would do better. Because there's quite a few people that are
Okay. Yeah. Okay. Sounds good. Yeah, we'll just have to cut more of the 12-inch, but that's fine. You could, but we don't want to use a 12 by 12 because then you have to cut off the outside, so you lose a certain amount of the outside. Otherwise, they won't be nice and square. So we'll make it like 1 foot by 3 foot, but we'll make it a continuous piece. It should be just the same as you were doing before.
So first attack.
Excuse me. You can do the tack coat and then the saturant, or the saturant and then the tack. We basically going to need them both at the same time. Because what we're going to do is, normally I would do the saturant first. I'd mix the saturant and then they can start saturating as someone else is applying the tack coat. But here we're all going to kind of do everything together. I don't know that it matters. Which one? The pipe that's already been coated? So chances are we're at a point where it wouldn't make any noticeable difference at all. Worst case, if it happened earlier, you would get water spotting, meaning like the finish would look like the gloss was uneven, or maybe it would have some chalky whiteness to it, but it wouldn't be it wouldn't ruin the structural integrity of the repair. If you want it to look nice, you would just have to sand it and then put on another layer of coating. And then I'm going to have you cut a couple more of the 12-inch wide pieces. They want to make some samples at the end. So yeah, you can take this back and then bring over the smaller, the 12-inch. At what point when it starts raining do you need to stop? Is that the question? Yeah. You can. It depends on what you're doing. No, we're going to make it to fit on here. So you can go about 100 centimeters or 1 meter. 4 layers. So 4 by 1 meter. So if I knew that there was a decent probability of rain and, you know, I had a small repair that I could get completely done before it was going to rain, by all means, you could do your repair. Like if you just had to do this and you had it done and then it was going to rain, it wouldn't be that big of a deal. You could come in the next day, sand it, and top coat it. If you're going to do a large section of pipe, you're probably going to want to get some sort of protection so that the rain won't get on it. Otherwise, you're just going to have to stop work way too often. It's going to be a pain in the ass. But you can get away with small jobs like this without having that cover because you only need one good day, essentially. And the repercussions of if it does rain at night are not that big of a deal. Like I said, you wouldn't have had to sand, but now you have to sand. But it's like take a palm sander and sand that. It's like less than an hour.
But it's still paint over it? Or?
Not if it rains. If it rains on it, then you can get that amine blush that happens, and you won't get the right adhesion of our top coat. So if it does get rained on, then you have to sand it.
If you have a regular job, like the contractors normally keep some big polythene sheet, and
Yeah.
when they find that it's going to rain, they just cover the whole area.
Yeah.
Whatever level they've done the work, they stop there, and they cover the whole area with a polythene sheet, so that
Yeah,
rain
just
doesn't
plastic like this.
Yeah. And then when the rain's gone, they
Yeah, then they can pick it off and then keep right up going.
Any swimmer? No? Not insurance.
We can go ahead and mix up saturant and tack coat. No worries. So let's just make sure we keep the rolls separate because they're all different sizes. So the ones that were 100, are they over here? Oh, great. Good, good. Okay, perfect. I mean, it's closer to like 6 to 8 hours to really get like tack free and hard. We did a coating on a wind turbine tower, and we left for lunch, and we came back, and it looked like pepper was sprinkled all over it because there was thousands of bugs all in this tower, like crawling halfway down trying to get out, like big dragonflies, and like I was just like, I don't even know. We were in the middle of nowhere, and I was like, oh, it won't affect the corrosion protection, and you know, they'll fall off over time, and yeah, yeah, it'll be fine. We said, just put it up. Yeah. We might.
You have to use a different fixing thing. Can you
No,
use the same?
you can use the same. So go ahead and start with the 12 by 12s. Yeah, the small squares. And you can saturate probably at least 4 of them at a time, or maybe 2 each. Don't go too close to the edge because it tends to make a mess, but you can easily fit 4 on the table. So you can't pull that one out because you're going to lose your... Yeah, but I would just get scissors and just cut it. Sticking to the floor over here, huh? This is the tack coat. Yeah. A lot of fumed silica in it. Yeah. It's going to be a little bit thicker than the 300 once mixed because the hardener side's a liquid. This one's very prone to splashing because of the big viscosity difference. So be careful, go real slow when you start. My least favorite product to mix. This is the tack coat. So the thing that makes it like hang on the walls and overhead.
So if you put your sheets in the wall, how would you do your overlapping on your sheets?
So I'm going to show you how we do the overlapping on the vertical seam. We're not going to be able to demonstrate how we do the overlap when you have one seam to the next. But like, if we did this and then we were going to continue, we would just do our 6-inch overlap. As far as like, we're going to work from the bottom up and we're going to do a 50% overlap. So we get 2 layers at a time when we go, as we go up. So our vertical overlaps are 50%. So mostly we use 25-inch fabric, so you basically have a 1-foot overlap each time, because you have a 2-foot fabric and a 1-foot overlap.
thick for the pantry.
Yeah. You might need to crank up the speed on your mixer. So go ahead and saturate all 10 of them. You can just stack them on top of each other over in the corner somewhere. So stack yours on top of his, otherwise you won't have any space, or however you want to do it.
So with this you want to fast forward.
Well, you need to go slow at first to get it incorporated, and then you don't want it chunky, right? You want to make sure it's all clear like that, and you're going to have to scrape the sides for sure as well.
So would you then apply this first on the tank side? Is that,
Yes.
okay. Then you
Then you're going to do this.
Grit blasted and clean and all of that, and you
Yep.
apply that.
It's going to be grit blasted, and usually there'll already be a coating on there that's our galvanic barrier. And then you'll use the putty to cove it and fill in any deep pitting on the wall. Then we'll move into the carbon fiber, and we'll do this immediately prior to putting carbon fiber on.
and a thin layer.
Thin layer, yep. No, this will it'll stay in place, even overhead. So if you put it like directly overhead, this will keep it in place.
One layer.
Yeah, this will actually keep a double layer in place. So I'll show you how we do it. So if you let it fully cure, so say we do 2 layers today, tomorrow you're going to have to apply this again. And then do your next 2 layers. If you happen to catch it where like the carbon fiber has tacked up and gotten sticky, you don't need the tack coat on your next 2 layers. But it's hard to catch it at that perfect time because usually it takes a while to get the carbon fiber in. It's a labor-intensive process doing the inside of a tank. But yeah, we would basically do this every time it's dry, and we start over on dry carbon or steel.
Ja, maar dit is ook nie gesê by ryk aan. Ryk nie self daai.
If you get a bigger mixer, they go faster too. These are very small, so they sell a bigger size of this similar mixer, and the finned mixers work a little bit better as well. That I can send you one, or I can just show you what they look like. You can probably source them locally. I just don't know where you'd find it. Like we can buy them on Amazon or at Home Depot, but I don't know what you guys have here.
You're getting Amazon soon, right? No, we got a tape lot, so. Yeah, like Amazon. Just the South African.
Yeah, that looks fine. Do they have paint mixers?
I think they've got.
Amazon's got everything.
Order from Amazon, it doesn't it? But we have to bring it in.
So maybe we need to see next time.
That's good.
2 or 3 words worth of shipment.
Yeah, like I said, we have them, and if you're already bringing stuff in, I can throw it in with the shipment, especially if there's no taxes and duties on shipping stuff in. It won't add much weight.
Depending on the amount that you bring in. Well, yeah, if you bring
Yeah, yeah. All right. We don't have any more roller trays, so you're just going to have to stick it in there. All you're going to roll it on is the sidewall. The whole thing, though. Not the floor, just the sidewall. And you don't have to go over the putty. All right, so we're applying the tack coat here. This is going to be what holds it on the sidewall. Nice and thin. And it doesn't really matter if it's a little bit uneven, it's fine, because it will cure at any thickness. We just have to make sure that we have some everywhere. So don't worry if it's a little uneven. It's hard to put it on evenly because of how thick it is. Yeah, he's going to do the entire thing. All the way to the top. And then we'll let someone else do the other one so someone else can see what the tack coat's like. Mm-mm. We're using adhesive, which is a real thin, a primer, yeah. Yes. Half gallon is usually the smallest that we sell. Just because packaging it up in little tiny packages is such a labor intensive.
It looks like it can be used by putty blade also.
You can apply it with a putty knife also, but this is way faster, even though it's a little annoying.
You apply that to the floor as well, that check?
Nope, don't need to, yeah. You could, but you don't need to. So normally on a tank, the first thing that we'll do is we'll coat the entire tank with an epoxy, because that's going to be our galvanic barrier. And so you can roller apply that or spray apply, however you want to apply the epoxy. So we won't need a primer, because the epoxy will act as a primer. And tanks are never high in pressure, because really it's just head pressure that you get in the tanks. So you mean that cylindrical tank where we did the outside? I believe they did use this. It's sometimes you don't need it. I mean, you saw how well it hung on the cylindrical pipe. Yeah, if you can go the whole way around the tank, then you won't need the tack coat. But if you want to do like a partial piece, then you will. Yeah, like on the very bottom. Yes, it is. Yep. Did you guys get all 10 done? Yes? All right. So what we're going to do with the shingles, you go ahead and coat that, because I'll let you do. So let's break up into two groups. So what, 5 of us total here that are going to do it? So I guess 2 people go ahead and start putting the shingles down on this one. You go ahead and do your tack coat, and I'll show you it again on that one. What you're going to do is you're just going to start on the ends. It's fairly close to the ends, maybe a little bit inside of that. So leave, a little bit of room. Always try to keep, so you see there's yellow strings on the side? So make sure that, no, that way is fine. Just do it the same each time. Yeah, go inside a little bit so that it's not overhanging the edge. And just be a little bit gentle on the putty, because it is definitely not fully cured. Yep. And so what you want to do is just...
Can you just explain that yellow line? Explain to him that?
Yeah, so the carbon fiber is sewn on the edges, and that's what the little yellow line is. It's where it was sewn on the edges. It looks better if you keep the yellow line going in the same direction, because they're squares, so you could alternate it or rotate it, but it will make it look a little sloppier.
It's not going to make a difference in that.
It doesn't make a difference in the strength. It just, so now you're going to do a 50% overlap. So you're basically going to put it there. I find we get more bubbles on tanks. But the pressures are so much lower that the bubbles usually aren't a big deal unless they're real big. Because a tank, you really just have head pressure. So you're usually talking about, 10 psi, maybe 1 bar, 2 bar. So now you should be able to see the line from your last one. So you want to just barely overlap it so that you get 2 layers everywhere. Exactly. Yeah, just a bit more than 50%. All right, once he's done, you guys do the same thing as they're doing. Do you see what they're doing?
Yes.
Okay, perfect. Each of you should do 5 pieces. Get out of everyone's way so you guys can see.
Who thought you could make money out of paper mache?
Nee, daar is nog Jan. Nee, ik kom niet zelf niet. Toen Jan, ik heb niet Jan contact gemaakt. Toen Jan voor 200 rand van contant gegeven, maar uiteindelijk 200 gebrek. Voor het ons het betaald.
I found those pictures on the floor under Andres' desk.
Really?
Yeah, so I was, no, there. So obviously when I went there, pulled out my wallet.
And
or
it fell
something
out of
and
your pocket.
Yeah.
Okay.
I thought we were inspecting the bottom of the
Whose love letter is that?
Ja, het
Oh, 200 rand, that's not too
All right,
bad.
are you guys done with all 5? All right, so now
Any day of the
let's go
week.
ahead and saturate a 12-inch by 120 centimeter piece, and then a 25-inch by 120 centimeter. So you're going to need both.
Onze customer te min gecharged, né?
The last time I did a Polokwane trip, I got an 800 rand fine going up and a 1200 rand coming back. It's like, and I hated it. It's just hard-earned money. You just
That's the sad part about it. It's hard. Just send an email to the municipal court. And we'll have it for you.
and they're reading right. Bottle dates next, definitely in the saturation.
Ja, absolutely. Suzanne, I'm sure she's stealing from you. It's part of the family, isn't it?
All right, so when you get the 12-inch wide piece, you're gonna start it way down there. Yeah, probably almost down to here, as low as you can go. Yeah, and you're just gonna go across. It should go. Yeah, I mean, there should be maybe a half a centimeter on either side of wood. Yeah.
Then if you do your second layer, then you put the corner in again.
Yeah.
Put that on again and that on, but you drop a bit lower.
So
There you go higher.
the first layer is going to be a 12-inch wide band. The second one, you're going to do a 25-inch band. So you're going to also start at the very bottom so that we get 2 layers in the bottom. And then I'll talk you through how you would continue if this was taller. Yeah, the tough part about these is as you push out an air bubble, sometimes you can create it elsewhere. So you got to be very conscientious. And if you're doing this in a tank, I definitely recommend getting knee pads if you're down on your knees. It's pretty close. It's eyeballed 50%. Yours is a little more than 50%.
But there's a lot of
Which apparently in the paper they
Only difference is you're using more pressure.
Well, this is right. We want to do more than 50%, not less than 50%. So, because we get 2 layers, we're counting this as 2 layers. So you're probably not going to want it on a roll here. You're just going to roll it up loose. But it's got a ton of saturant on it. Whenever you're going close to an edge, it's a pain if you have it on the roll. But as soon as you got up to like the 3rd layer, which we're not going to do, then you would definitely want it on a roll. Yeah, exactly. You don't have to push all the saturant out of it.
the same was meant to happen with Mohammed Bashir.
The bigger piece now, yeah.
So then that side requires 12-inch, 2 12-inch pieces, and then 2 24-inch pieces.
Now I'm going to show you how we do it. So watch how they do it. They're going to put 1 12-inch across the bottom.
Bottom first.
Yep. The bottom. As far down as it can go. So we always work our way from the bottom. No, sorry. The sidewall, but as far down as you can go. As close to the weld seam as you can on the sidewall. Yeah, because we're really close to the floor, so the roller gets in the way. Once they get farther up the wall, the roller's nice. Roll it on the edge. Yeah. It's not as bad. It depends. On the 25-inch pieces, it's really annoying because they fold over in half. On the 12-inch pieces, it's not bad without a roll. Well, we start off with the 12 because we need the tack coat for it to hang like this. So now, but we don't need the tack coat for the whole length of it. So this is why we start at the bottom, because the top basically has the tack coat. So it's not going to like sag down and flop off. The bottom, we're just going to have saturant to saturant. And this is how I recommend doing it when you're doing this application. One guy is essentially guiding the carbon fiber, and the second person is, rubbing them out the air bubbles and ensuring that they're gone. because this first person, that's fine. The first person just needs to concentrate on keeping it as straight as possible. Like when you get into an actual tank, it's really hard to keep this thing nice and straight. Yeah, it's like going up and down. We've tried using like laser projected levels. Yeah. No, you can't. I wish it would be better, but it's just not practical. Yeah, and then we offset where that overlap is on your next section of layers.
How long would you make those sheets?
Um, as long as is practical. So what we've typically done was about 2 table lengths, so about 15 feet. If you get an 8-foot table, that seems to be about as long as you want. Because if you get longer than that, it gets real heavy. So the guy's arms get really tired.
So the next brick would be
Yeah,
50% of the
roughly. Yeah.
seams would be replaced.
Yes. Yeah, roughly 50%. So you would do it on this. So we're going to get 2 layers. On this double layer, all your seams are going to be in the same spot. On your next double layer, your seams are going to be offset 50%. So if we were doing this in the tank, you would do another 12-inch, and you would just have a 6-inch overlap, and you'd keep going until you made it all the way around the tank. And then we would do the second piece, which is going to be the 25-inch piece. And the 25-inch piece is also going to start at the exact same spot on the bottom. And then it's going to go up to maybe here. So we're going to have 2 layers in the bottom. And then the next piece you would put on, we don't have enough room, would be another 25, and it would start just below this seam. So you can see your seams if you push your carbon fiber in. So you can use a visual guideline to know where your overlap should be on the next piece.
Where those things are overlapped with shingles, they'll have 4 layers on it.
Yep.
The rest of the tank will have 2.
Yep. But the floor-to-wall joint is always one of the weakest spots. So if we can put additional reinforcement there, that's fine. What we would typically do is before each layer, we do this seam. So if you're going to do a 6-layer situation, you're going to do shingles, do 2 layers. The next day, you're going to do shingles and 2 layers. So you do get a lot in the floor-to-wall seam. There's no doubt.
So all the work technically goes into doing your seam first and then refit it. It's much easier.
I mean, these don't take that much time. You guys just put these on in like 10 minutes probably to put 5 pieces. Like, now, it's going to be like 120 pieces if you go around a decent-sized tank. But if you can put them on in a minute or 2, you're only talking about 2 hours of work. And typically what I've seen is multiple people, because this is really a one-person job putting that shingle down. You don't need 2 people. So you could have 4 people doing it at 4 different spots, and each person does a quarter of the tank. So it goes quicker than you'd think. As soon as you get to these strips, you need 2 people. All right, let's saturate 25-inch wide. The wide. Looks good, guys. So your next piece, guys, is going to go, you're going to start at the bottom at the same spot. So you're going to start way down here at the bottom, but it's going to go up to maybe here because it's going to be a wider piece. All right? So it's going to overlap that piece you just put on completely.
But from this angle here.
Yeah, from the same seam. Yep. If you do ever get a square tank, though, you can just do 1 strip, and it's faster.
Are you with the top of this? Are you going 50%? 6 inch.
So you're going to be doing, on your first layer, it's 100% overlap. On each layer going from then on, it's going to be 50%. So you're basically getting 2 layers everywhere. And then at the very top, what you're going to do is you're going to have to put an extra 12-inch band at the very top to get that last the last 50% overlap.
Suzanne? You came all the way. You just explore. Take a drive for a change. No, not as yet.
So what we should do is, at least for the application people who went through the training, we actually put together like a certificate that they completed the training. Because for PCC2, you need to have training from the manufacturer. So now we can show. So if at some point, yeah, just send me the names. I'll put it on. If you have it, that's fine. If not, I don't need like any official. This is just so you could show your client, yeah, hey, my guys were trained by the manufacturer.
They would normally prefer a full name and an ID number on a certificate. That sort of is the game
Because we
they
need that for our safety file as well. So we have to some safety documents when we work on site.
Yeah.
Okay.
Which is all your ID. So we have to get some example PCCs from you, quality control.
Yep.
We'll have to issue those, some safety file, procedures, safe working procedures. I'll give you a list of stuff report. The medicals of them.
Okay. Okay.
Just want to make sure. So if I continue, is this my base? So I first put my blocks down,
Yep.
right around,
Yep.
and then I do that part, and then I do the second part, or the third part where the full section goes over, and then I move on.
Yep. Yes, exactly.
So
Just down to there. Yep. Yep. So yeah, the next piece, if you did it, it would basically overlap from here
so then
up.
so it's only on the board in the 12.
Yeah.
As you go up, you start moving to the 25.
Yes.
Then 25 needs to go half foot.
Yep.
And
So
then you're going up and up and up and up.
exactly. So the rest of the way up, you'll use 25s until you get to the absolute very top of the tank, and you have to put one more 12.
So it comes down to you putting 2 layers
Yep.
as you go up.
Yep. Exactly.
Covering that 30% down.
Yep. What do you mean? If you do the inside of the tank on top? Yep. It's very rare that we use composite on the ceiling of the tank. Most of the time, the ceiling, it's not holding pressure, right? It's just a containment, essentially, keep the rain off and that kind of stuff. When we've done the ceiling of a tank, we've done it externally, which is a much easier application. But if you did have to do it internally, you could do a similar procedure. It would just be a big pain in the butt because going overhead is much harder than going on the wall. So if anyone needed you to do that, you would just have to know that the labor is going to be significantly higher because it's just going to be slow going, putting it on the top. Possible, but slow going. Yeah, on the ceiling, really, you can only layer one layer at a time. You can't even do this 50% overlap on the ceiling. So you see how you can see where your seam is now? Yeah, so that, if you put your next piece on, you would go just past that. Yeah.
Just pass 1 inch, 2 inch.
Just past it so that you're clearly past it. You know? What I would do, ideally, would line this yellow line more or less up with that seam. You know what I mean? That's what I would try to do. But you can go a little extra, but not a little less. So that's all we do with the tanks. Like I said, you just would keep going the whole way around, and then keep building it up.
So this is technically, so if I imagine now this is the top, and I turn this around, this will be my last section, and then I put another 12 over.
So if this was the very top of the tank,
Yeah.
right now you have 2 layers here, but you only have 1 layer here.
Yes.
So you would just put a 12-inch piece right on top of this area where there's no, because right now you only have 1 layer from, there's about 12 inches.
Then I need to cover still the 50% going to the top.
Really what we're just trying to do is get 2 layers everywhere, right? That's the 50% overlap is designed to create 2 layers. You don't typically, no. Typically you'll just terminate at the top.
So terminating, if this is my top, I just put the last 12 inch section.
Yep, and then you're done.
Give me that 2 inch, the double layer.
Yep.
Okay.
And then we'll always top coat it. So after you're very done, there will be a coating that's going to be applied that's going to go from the wall off into the ceiling. So it's fairly common to coat the ceiling. It's not very common to composite wrap the ceiling.
So basically, if your tank is too there, you only start. So
Yeah,
that's
you-
your border, you won't pass that.
Yep.
You just need to make sure that this stops there.
Yep. The only other thing to note on tanks, when you're doing tanks, there is always interruptions, right? There's no tanks that have no manways or no inlet pipes, because if it was, what's the point of that tank? So when you get to like a manway or an inlet pipe, you saw in that presentation on the inlet pipe, we put additional layers of carbon fiber. On a smaller inlet pipe, it kind of looks like a hashtag. You'll put 1 strip on either side and then 1 strip across the top, and that will give us extra reinforcement. A manway is bigger, so the 2 pieces won't be enough. You have to put about 8 pieces. So you go like this way and this way, that way and that way, and then kind of at diagonals. That makes sense. What you're doing is you're basically putting a layer, an extra layer of carbon fiber all the way around whatever that penetration is. The carbon fiber doesn't really curve, so we have to do it with straight lines. It curves a little bit, right? But we basically put straight lines around that interruption to reinforce. We do that between every layer. So we did 2 layers here. If there was a manway right here, we would do that extra pieces, and then we would do the next 2 layers. Then we would put those extra pieces on, and then we would do the next 2 layers. We put those extra pieces on, and then you can top coat it, and you'd be done. So it's hard to demonstrate exactly. I guess I could have had you cut like a hole in one of these, but next time. But you saw a picture of it on the presentation, but that's the only other thing on the tank that we didn't really teach you.
Can we do the same as we did now, the 12? Cut it in sections and
Yeah,
it's
so
gonna bend more easily.
typically what we use is a 12 by 24, so it's twice as big, not very big, but smaller pieces for that reinforcement. And you can just work your way around on the manhole. So you don't have to go 1, 2, 3, 4, 5, 6, 7, 8. You can just go, 1, 2, 3, and work your way around. So as long as you get that entire seam sealed with those pieces, then you're good to go. All right, go ahead and put your last piece on here. While they're doing that, we are going to make a few samples for show and tell for the customers, which are what those pieces are going to be. So I'm going to have you saturate, and then you're going to put it onto there. So we'll need another table. I'll set this one up for you if you guys want to start saturating these pieces. Oh, those are extra. So those ones are the ones that we want to. What's that? I am going to need a table. We can just clear this one off. So let's just take all this stuff off.
Klinger sticker and they use it as a coaster, you know. So yeah, no, you ask them later, we're going to make our own samples and then we're going to wrap a pipe on it, PVC pipe, and then cut it in pieces. And leave the wraps out and we can.
All right, guys.
How are we going to do this now?
Yeah. So what you're going to do is, I was just going to get a rag to wipe this down to make sure there's no dust or debris. So making a sample, you don't necessarily need it on a roller, but it's fine.
Yeah, it's just to store it the while I'm carrying it.
Yeah. So just start, a little bit in from the end, in the middle, and just roll it out, and just work any bubbles out of it.
Where do you want it?
So just, put it right in the middle of this thing.
Okay.
But like a little, do it that way. Yep. Yeah, but not hanging off the end. So go in a little bit more, so it's not hanging off the end. All right, that'll be fine.
As hy so na say 5 minutes. Wherever there's a bubble, then you can polish it out. After 5 minutes after your first layer, more or less 5 minutes, then you can see most there's a bubble, then you can polish it out there. Also, hier nou nie Kalahari woestyn is. On top of each other.
Yeah. So you're gonna, so you're just going to do this 4 times, all right on top of each other. Yeah, so this is just a sample that we're going to cut up, and it's for show and tell for customers, potential customers, to kind of just touch and feel and see what the carbon fiber's like. So guys, I would wait until probably Monday, and on Monday, just bend that, it'll pop right off the sheet. Yeah. And then you can get the tile saw, just make sure it's water cooled, just tile saw, you cut it right up. You can do whatever you want. You bought it. What is that? Can you like take whatever that is off, or is that a? Oh, it's a break in the fiber. Okay, that's fine. It's in the middle, anyways. Yeah, that's what I was going to use for samples. If you're at 4, it's got like a nice stiffness to it, but it's not super thick. So it's kind of my default for samples.
Just peel it out of that surface, then once it's dry.
Yep, it'll peel right off. Yeah.
It'll have a smooth finish.
Yeah, that's how I created those ones that you saw upstairs.
Yeah.
I did it on like a polyethylene table, but this will do the same thing. What saturate you guys got? Plenty. Okay, good. So I think there's 2 more pieces here. I'm going to have you saturate one of these and wrap it up on the bigger tube, and then we're just going to leave it on that tube because it's going to be a cylindrical sample that they can cut up. Does that make sense? So did you get any material on you, or did you make it through both days of training without getting? I always ruin my clothes when I do trainings because I hate wearing these Tyveks.
Like I'm used to hands-on training and hands-on coating coating. So to enter the tanks and spraying with the printers. So like I'm pro in that. So I know how to. You know, if you're not used to it, like you get promoted.
Yeah, people all the time scrap things. I don't touch anything.
Like I used to go inside and show the print how to spray. Because there's a lot of techniques required in that. Overlap and all that, how to build the thickness. Every coat check the WFC. And also, no need to just wait till the
So take that little squeegee and try to just smooth it out a little bit. That's enough. I think so. But just try to smooth it out a little bit. That's good. We're going to cut off the edges anyways, so I don't really care if there's a little extra on the edges. Yeah. Yeah, it is what it is. It looks fine.
Halfway there, but not really.
No, it's good. I mean, like, there's a little bit right here, but I don't know that it's, like, necessarily worth, there you go, messing with it. It's one of those things that the more you mess with it, the more it gets messed up. No, that'll look good. So we made you this 1 foot by 3 foot sample, and then 2 that are on tubes as well.
Okay, yes, yes.
Those are all for show and tell. You can cut them up, whatever you want to do. The big ones here are a little harder to cut. Depends on how big your tile saw is. If it's big enough that you can just fit that into it, you can just slice it right there. And then you can slice little like cylinders of it. And this tube will come off if you want. After you've cut it, the tube will come off. And you can also cut them in half if you want a half circle, however you want to share them with your customers. But it's good for show and tell. And we already had saturate mixed, so might as well.
So what does that cost us?
You already paid for it.
How much would it cost us?
Carbon fiber, the 12-inch, costs about $800 a roll. The roll is 50 yards, so that's 800 divided by 50. My head's not working very good right now. $16 a yard. It probably takes 1 yard to make one of those. So you're talking about $16 to $20 worth of carbon fiber.
Ja, maar voor die hele rol. Opkat. Nou, dat is veel sidekick wat ik hier. Ik heb het verleerd die ik praat goed aan zijn. Ja, die praat veel 100 jaar. Not 5,000. 500. 500
About 10,000.
For repair again?
We would charge more than that in the States, for sure, to do a repair like that. Maybe $2,000. But I think stuff's just a lot more expensive there. So, you know, 500 to 900 might be a better price here in American dollars for a repair like that.
What price can I buy a second-hand, kind of old car with about 200 miles in the States?
With only 200 miles?
Yeah, 200,000 miles.
200,000 miles.
Yeah, 200 miles, basically.
All right, everyone. Thank you so much for your time and for your attention. A couple of things before you go. This is my card I'm going to pass out to everyone. It has my email and my cell phone. If you have questions, ask. Pictures are worth 1,000 words, so if you're doing a project and you're unsure, we do have a bit of a time differential, but feel free to send pictures. Morali is also available, and he has more overlap with you guys in terms of your working day. So if it's in the morning, Morali is a great one to reach out to. If it's in the afternoon, you can reach out to me either way, or you can just CC both of us. But if you have a question, don't just guess. It's definitely worth spending, the 15 or 20 minutes, especially as you guys do things that are new. Also, typically for tank reinforcement projects, we've done some training on tanks. If it was a fairly, not a very complicated tank, I'm sure you guys could handle it on your own. We do come out and do technical oversight on projects as well. So if a project is complicated, if the scope is big enough that it makes sense, because we'll help you be a lot more efficient too. We can talk you through some of the application inefficiencies that you might see when you're doing a big project. So keep that in mind. We'll always give you advice. If you can take pictures of projects and send them to me, it's much appreciated. It really helps us market what we do. And if we can market it effectively, it's going to help you as well. Because as we get leads, if we get opportunities, so you guys are our exclusive partner in Sub-Saharan Africa, or I think in South Africa for now, and then we don't have anyone else in Sub-Saharan Africa. So the hope is that is it already all of Sub-Saharan Africa?
We do Sub-Saharan Africa,
Okay.
Madagascar, and Mauritius.
Okay. So you guys are our exclusive partner in this region. So if carbon fiber work comes up here, you guys are going to be the ones doing it. So don't feel like, you need to hide any of this. It's all out there. We're going to try and build opportunities and leads. We already have some opportunities I've been talking to your staff about. I'm really excited about the potential. You guys did a great job. I could tell you were paying attention, asking good questions. We did good work out there. It went much faster than we were anticipating as well. So normally when people are new, there's a bit of a learning curve. You guys seem to really hit the ground running. So I appreciate that. I appreciate all the hospitality. Bringing us out for a few beverages after training is always nice to be able to chat and relate with some of the people. Before we go, we really like to get feedback on training. That's how our training gets better and better, is if we get feedback from you. So a couple ways we can do it. We could just go around the room and each person could just say what they thought about it, or if people are feeling outgoing and want to just shout out things that they thought about the training. We're absolutely open if there's something that would have made sense somewhere else or that was hard to understand. Let me know so that hopefully in the future we can correct that. Any preference? Do you want to just kind of go around or? The reason I like to go around is because then people don't say anything unless I force them to.
So the training, all in all, from my point of view, 100% good. Very interactive, explaining exactly what we need to know. On hand, guiding us as well. Just a better perspective for the tanks. If we move forward and hoping to do it technically, if we're sitting in that time frame again, just a better layout for the tank as well. Because it's still vague to me, but I do understand what's going on there. I don't want to press a button 1 o'clock in the morning and find someone where there's just a physical representation or just a drawing that indicates to me what I can see, but that needs to be that way.
Yeah, no, totally understand. The tank mock-up we made, that's actually the first time that we've done a tank mock-up like that. It was certainly better than nothing.
Yeah.
But I think if it was a little bit bigger, that would have helped. But it's hard to make like a cylindrical tank. So maybe if we had a slightly bigger rectangle. You mean so you could see how we kept going up?
Yes.
Okay.
But even if we can't go further, then a drawing will be actually more sufficient to us as well.
Joint meaning,
What's it? Picture sketch.
okay, a drawing. Yeah. Understood. Okay.
Yeah,
Thank
maybe
you.
something similar to that. The drawing you showed on the pod where you layer it or stack it.
Yeah. Can you make some notes for this?
Just going to send you into the bank and say, with Rusty and David and everyone on the team to say how we must do it and put a procedure together to say,
Yeah.
you do it this way. But we're not going to say to you now, jump in there, do it.
No, but for the first time, just to get a drawing, just to stipulate what's the right procedure. Because if he's gone, it necessarily doesn't mean I did understand what he's saying to me. So a drawing helps in other sense to say you have to do it in that step.
Absolutely. And the drawing we have for the pipes, like you said, showing the layout of where the layers go and how we offset, we could certainly create something like that for the tanks. So yeah, I'll look into that.
Because it's more concerned of when you stop and to continue. That we at least know what to look for and how we need to work towards that.
Okay. One thing I will say is, you kind of touched on it. Before you do a job, there will be a detailed specification. But it's hard to understand that specification unless you've had this training. So now that you've done it, you know what a circumferential band is. You know what we mean by like an axial overlap versus a circumferential overlap. So it's easier to read that and understand that specification. Whereas before you would have just been like, I don't really know. So we will have detailed specifications. Now, if you do an emergency repair on a water pipeline, oftentimes there's not time to put a specification together. But when we're doing work at refineries and things like that, we have a ton of specifications already written that you could use or that we could submit if they want to have something on file. So whatever we want to do, we'll write custom specifications. It's a big advantage to us to be specified. So we'll do that for free for the refineries, for whoever, chemical plants, the power plants. We'll write up a specification and obviously name ourselves as the pre-approved supplier. But it's a good opportunity if you have customers that let you help them with specifications. We'll write you up a really good specification. You can just say, here you go. This is how you should repair your water pipes.
Yeah, just from my side, thank you very much, Russell, to the HOD's department. Thank you once again for the opportunity to sit in and to be part of that great experience. Training was good, very informative. I think every job is going to come with its own challenges, but like we said, specs and all these other things will be given, and I think also to say, it will be safe to say when we get to that part of the job, I think that the learning part will also be when you are on the job, because there will be people scoping the job to see what is needed. But for now, I think the basic level of training has been provided, and I think in the field it's a different thing, because tanks or pipes, whatever we will be dealing with, so. But from my side, it was fairly informative, and looking forward to know more about these products. Thank you.
Awesome. Yeah, I think that's a really good point. It is impossible for us to emulate or to replicate every obstacle you're going to face in the real world. You are absolutely going to face obstacles. Most of the time, we've done a lot of pipe wrapping as a company, along with our application partners. Most of the obstacles you're going to encounter, we've seen before. So that's why if you encounter something, you're not quite sure how to deal with it, we've probably already seen it. So ask if you anticipate an obstacle, if you know you're going to go over a gigantic flange or, some odd geometry, ask in advance. We may be able to tell you right away, hey, this is what you have to do. Every now and then you're going to run into an issue we haven't seen before, and we'll solve it together. Please inform me if you're having issues and you solve it, because then, I'll learn. I might identify something that, you shouldn't be doing, or, I might learn something new that really helps. So the more we communicate, the better. Like, we really want to have a partnership. This isn't going to be a relationship where you just send us POs and we send you material. There's going to be some back and forth. For the salespeople in the room, if you have a customer that's kind of uncertain, they're like, this sounds like a good idea. Sometimes they're like, it sounds too good to be true. Does this really work? Are you just selling me, wishes and dreams? We can do a Teams conference, and I'll come on and do a presentation and show them, and sometimes just being able to answer their questions and having the experience and the confidence, because we've done it a lot, can really help seal the deal. If you can sell it on your own, fantastic. But feel free to call in, your backup. I'm very willing. Morali is very willing as well to help you with presentations. We can provide you a presentation to give. If you're having a difficult time finding opportunities, I can kind of cue you on some of the questions to ask, or some of the areas in the various plants that we've had success. So, there's going to be a lot of learning, both for the field application crew and for our business development team, to try and make sure that we continue doing more and more wrapping work. As you do more and more here, it's going to get easier and easier to sell. I often find the first job you do in a plant is usually on the smaller side, and then they get a little trust in the solution, and all of a sudden they're doing larger and larger things. So there's big opportunity out there. I think it's a great partnership potentially here, and we're excited. Thank you for the comment. Anyone else?
Why must I always talk? I'm enjoying other people talking and trading.
All right, that's all I have. So we're done a little early today. Like I said, really appreciative of your time, and reach out if you have any questions, if you think of something. I got a 14-hour flight home, so I'll have plenty of time to respond. Thanks again.